for the lab and any additional content required to finish modules on storage and databases we will cover after lunch. But just to give you an idea of the next part of the day, lunch in 2 hours minus 10 minutes. So 12:30 British Standard Time. But until then, let's finalize serverless computing with Lambda. We had a couple of mentions in chat as well, and very good ones, of course, because what we didn't mention here, and it was my intention after the break, is to ask, why then don't we use Lambda all the time if it's so efficient, so precise, and overall so good? It's because if we kept on running this Lambda function, eventually we would hit a specific limit. And as Dave mentioned, that is a 15 minutes limit. Lambda functions can't run for longer. You can configure the timeout to be shorter, but not longer. So if I go to my Lambda function here on configuration, you will notice, let's see, I can edit the amount of memory, the amount of local storage, and here, Andrew as well, I believe. Technically, I can have more than that. I can have 10 gig of local storage as well. So we could process larger items. But as best practice, we should keep it towards the small size. Likewise, the timeout. Yes, I can make this 900 seconds, or okay, 15 minutes, and no more than that. But the idea is to keep it on the shorter side. Quite simply, if you have a Lambda function running on average 10 to 12 minutes, that is not according to best practice. It should be close to as little as possible. They're meant to be fast and quick. Let me put it in perspective without going into too much detail as well. This is code that you write. You can quite literally write any code that you want here, of course, within the limits of the deployment packages, 50 gig zipped, 250 unzipped, 10 gig if it's from a container image, different limits as well. You don't need to remember the exact values. But best practice, let's imagine this code interacts with a DynamoDB table that we will actually learn about shortly. You could write the logic for get, put, post, delete, all in the same Lambda function code. But that would make it a little bit bigger. Ideally, all of these will be their own independent Lambda functions. So having them as such, as opposed to something like this, is regarded as better. This is the best practice choice, ultimately, for your logic to be as granular, segmented across Lambda functions as possible, as opposed to, like we said, having it all in one place, because this is just taking us towards the serverless monolith approach. And again, that's anti-patterned design. This is really high level though. So we won't go into exploring serverless quite to that detail unless you want to in a lab time as well. So a more separate discussion, if you will, simply because it would steer us too far away from the course. Miha, to answer your question, if there's a memory limit, yes, also about 10,000 megabytes of RAM, 10,240, I think. Yes, to 10,240 to be precise. And proportionally, the CPU will also adjust as well. Does that make sense, Miha? This one right here. And that's what also influences the price per millisecond, by the way. So more memory, more expensive millisecond. Right. That's about as far as we go into Lambda. There is a lot more that we can address here, private connectivity to VPCs, variables, encryptable code signings, different types of invocations and concurrency, and more. It is a big service. It is a deep service. But really, for architecting, all you need to know is the fact that it's serverless compute that is running code in response to an invocation. Many serverless services and others can act as the event source or what can trigger Lambda. And remember, it's a point and shoot kind of solution. It's meant for quick processing of small amounts of data or requests. Even though you can make them bigger, the design is meant to go towards the smaller side. Really, if you have a Lambda function that goes kind of towards this period or really lots of minutes, you should probably consider containers at that moment in time as well. So everyone, Lambda and other solutions such as API Gateway, for example, we really explore a lot more in developer-related courses. So developing on AWS, DevOps engineering, developing serverless solutions on AWS, those really dive deep into these services. And Andrew, we have a question there. Where do we see errors? Well, usually in CloudWatch. That's where we would see. In CloudTrail, we would see API call invocations. So technically, you could see some errors there, but more often we would look at them in CloudWatch. Even the logs in CloudTrail, we could send them to CloudWatch logs. There we are. If you can see here, the inbuilt metrics will tell us how many errors we had. More detailed ones. Yes, we could technically take them from CloudTrail for the API calls, but more function-related ones, we could see them in CloudWatch logs as well.
Okay, thank you.
No problem at all. And Nikos, 70 million requests to process and store to DynamoDB. Is Lambda a good solution? Yes, that could be a good solution there, Nikos, as well. Again, it always depends a bit more in granular on the use case, but yes, it could very much work. Actually, I know this is taking us a little bit on a tangent here, so I will just show you this, Nikos. And if you want to explore this further, and anyone who wants to, let me know, and we can spend time during the lab to look at this further. This is a serverless solution right here. It's a note-taking app that you can write to, and it's basically a few Lambda functions that interact with the database behind the scenes. In very simple terms, it actually is this architecture fronted by an API gateway, and the requests go to a DynamoDB table. This is what we're looking at there. So if I create a record, that triggers one Lambda function with a put item to DynamoDB. If I delete a record, it's a different Lambda function. So, like we mentioned, we can explore those further if you want to, but separately, as this is quite off tangent. It's basically part of a different course, really. Does that make sense, Nikos? And are you happy with that as well? Yeah, absolutely. We will do that for a few more minutes at lunchtime, just so we don't steer too far away. And Anthony, yes, we can enable X-ray as well. You know what? Let's show this also. We will see this in the monitoring module later on. But just to answer the question, really just going to show this here. There we are, service map in X-ray. And we can see Lambda. So we will see this in more detail later as well. Anthony, are you happy with that? I'm not sure if you can hear me, Anthony? Yep, that is perfect. All right. In that case, everyone. So, Jacek, I'm not sure what you mean by lambda replications. So how do you...
if you have, for example, in the Boston ECS service, we can set up that service is launched as a two copies and works parallel. So the same for Lambda. I'm not sure if it's possible.
Yeah, so we can have multiple Lambda functions running at the same time. Basically, it's the same code running multiple times. And exactly as Nikos mentioned, that's what we call concurrency.
Okay. Yeah. Thank you.
No problem at all. Now, everyone, as we have covered compute and various tangent services relating to it, really addressing these technologies here, Lambda, EC2 instances, and more, the way we pay for these. We haven't covered storage for it, but we will do so shortly. We will now move over to talk about other solutions, such as storage. So, if you have further questions on Lambda, more than welcome, but we will address them as extra learning because, quite simply, it's they will be beyond the scope of what we have to go through, essentially. So, everyone, let's talk about storage next. Because ultimately, we talked about where we compute data, how we connect elements together. What about how we store? So, what are you aware of using yourselves? A little bit of A, mostly C, and a little bit of B. Okay, so databases, interestingly enough, will use a form of block level storage. If we have databases, we will definitely be using block level storage as well. So, a form of A. Databases will use a form of A, of block level storage. And let's have a look at generically these storage options. And in the next module, we will actually explore databases in more detail. So, everyone, we will help our storage team lead look at some services about block, file, and object storage, what the right solutions are for different use cases, and different options for file-based, and as well as moving data in the cloud. So, what options do we have? Let's have a look. Let's save this and get a new canvas as well. And let's save this. I have a document on which I write Amazon. And I want to make some changes here, such as make the A into a 4, capitalize the Z, and add an exclamation mark. My resulting changes will look like this: AM or ZON, exclamation mark. This is what we refer to as block level storage because we've adjusted the individual blocks of data. On AWS, we work here with Elastic Block Store, which is basically storage for our EC2s. Conversely, if we take the same file here, whose format isn't actually important, doesn't matter if it's a Word, PDF, or anything else as well, we make the same changes and we end with this solution. Z-A-N for Z-O-N exclamation mark. Technically, the same end result. But what is the difference here? We have overwritten the entire object. So this is object level storage, and on AWS we use Simple Storage Service, or S3, for that. So let's look at Elastic Block Store first with EC2 and EBS as the Elastic Block Store, which, Arslan, you're absolutely right, can be backed up in the form of a snapshot. So let's explore these aspects. Let's get ourselves a region with some of those availability zones. There we go as well. And let's have a look. An EBS volume will have to live with the EC2, where the EC2 lives, in the same availability zone. Because EBS volumes are technically network attached storage. As you can see, I've drawn them separate, and that's for good reason. It is storage attached via the network. So technically, the physical layer is separate for the storage as it is for the compute layer, for the EC2. If we were to have a look at one of those data centers again, let's have ourselves some physical servers here. There we go, there we go, there we go as well. Technically, if we have ourselves the EC2 and the Elastic Block Store, this is how they would relate to the underlying hardware. Maybe something like this. They would be attached via the network across the data center, in the same availability zone, of course. And this is where it gets interesting, relating to those previous discussions. So I think Bhavdeep mentioned, if I stop or even terminate the EC2 and I keep the Elastic Block Store, because being separate, it can persist through those stages, and I get another EC2, or simply restart that one, I can attach it to this volume. But the difference is, this time the EC2 comes from a different part in the data center, maybe from here. So this is how it's dynamically allocated throughout the AWS availability zone, but it will still be connected with the volume, with the Elastic Block Store volume. Being separate means it can persist in that respect. Now we have another type of volume, and that is optional, whereas EBS is required. So let's say required. There is another called instance store, which is kind of here. It's physically attached. It's direct attached storage. So it's physically attached with the compute layer that it's coming from, meaning here and here. Because it's physically attached, it is also ephemeral, meaning if this EC2 is stopped or terminated, the data on the instance store is lost. So it doesn't persist in that respect like the EBS does. However, which one will be quicker to access? Again, at a microsecond level, of course. So if we're talking about this example, which one would be quicker to access, the instance store or the EBS? The instance store, absolutely, it's right there, the direct attached storage. And it is meant for that kind of access, for rapid, quick access in the sense of maybe for caching or high performance solutions. But remember, anything you save or generate in terms of data from it, best to move it to an elastic block store volume. If we have a look into the console as well, when we provision an EC2, for example, we would see exactly those details. So if I go to my EC2 here and I disregard the previous elements of configuration and jump straight into storage, notice I have an EBS volume. I can add another and another. I can change their sizes. I can make them bigger, smaller as well. It's flexible. It's, as the name implies, elastic. I do need to have one EBS volume at least. It's the root volume, basically where the AMI installs its software. But if I want an instance store, I have to choose specific instances that may have an instance store. Now, it's something to check documentation for. So I know C5D large has an instance store. Technically, you would see it in instance types here. It would show you the exact storage items because, there we go, C5D has an instance store, which I can't do anything about. I can't remove it, I can't add more, I can't change the size, I can't change the type. It's physically attached. I would need to have the keys to the data center to actually modify this in some way. EBS volumes, though, still flexible as before. And EBS volumes come in two broad types and about 6 smaller types. So we have solid state drives as the faster, more expensive option that come in provisioned IOPS and general purpose SSD volumes, with provisioned IOPS being the absolute most performant. They come at a 256,000 IOPS in the most complex in the most powerful configuration, and 4,000 megabytes of throughput per second. Whereas on the other end, on the cheapest, slowest side, we have cold hard disk drives at 250 IOPS and just as many megabytes per second. But of course, they are designed for archival solution, throughput-oriented storage, whereas the provisioned IOPS really for high-performance compute environments and sustained performance. Generally, though, we tend to go with general-purpose GP3. Kind of like with the instance types, GP3 is a newer generation than GP2, almost a net positive to go with GP3. So everyone, that is Elastic Block Store as a solution. But let's have a scenario here. Well, kind of a scenario, if you will. Actually, Andrew has a question. I found the server network bandwidth limiting.
Yes, so probably best to explain this one. So we've got a database cluster, Teradata database cluster. We've got about 90 terabytes on it across 3 servers, and it splits. It has 24 EBS volumes per server, and we've been trying to get the throughput increased on that server, on the servers generally. So we've increased the IOPS and the throughput on the physical EBS volumes, but what we found is the actual server itself has a limited network bandwidth, and that's the limit. So it's not the I/O; it's actually the server that's causing us the constraint just now. I think that's what's happening anyway, but it's difficult. Yeah.
That makes perfect sense, Andrew. It seems like at 24 volumes, you would have quite a large throughput, aggregated throughput indeed. So for 1,000 megabytes per second here in the maximum, let's even take 1,000 here. That's 24,000. Do you know the network card on that EC2 by any chance?
It's a R5i 12x large. I think it was 40,000 megabytes per second it handles per server.
So this is the capability of the instance, this throughput here.
Yeah.
Let's check something, because that might be an elastic network adapter whereas we can have something more complex, faster as well, an elastic fabric adapter, such as, let's see, do we have it here? So give me just 1 second there, Andrew, to see if I can show you this. Basically, the network card seems to be limiting here. Potentially might be probably not the best solution to have multiple network cards, because then you might have to configure routing and all the rest of it inside your EC2. Okay, so it's not here. That's right. What I was thinking is, there are multiple types of network cards, with the most powerful being the EFA at 100 gigabits per second as a capability. So if we have a look, transit gateways traffic. Network interfaces, there we are. So this one right here, so elastic fabric adapter. And in terms of performance, let's see if it's been updated. 15 gigabits. Okay, so it doesn't mention speed here. I will check documentation exactly, but this is the fastest one that you could have, and it should be able to hopefully handle it better. The last thing we need to check is if we can actually provision it for that specific instance. But we should be able to check that when we look at instance types as well. So I think you mentioned R5i or R5.
Just R5, yeah.
Yeah, let's go with R5 like this. Up to 1025. And was it 12x large? There we go, 12 gigabits. Yep, there we are. We would have to check. It does mention 12 gigabits, but that might be the default. So we would have to check if this supports the ENA support as well. So that's the middle one, elastic network adapter. Like the ENI is the lowest, ENA middle, and EFA the biggest. But we'd have to check if it supports that as well. If it does, hopefully that should improve throughput.
Okay, interesting. Thank you.
No problem at all. And let me send you this also. There we are. So very interesting use case. Indeed, here there are quite a few volumes, but of course it may be needed at those 90 terabytes. Do you know, you mentioned a clustered database. What kind of database is it?
It's Teradata.
Teradata. Is it a SQL solution?
Effectively, it's just a big relational database. So it's originally the company does appliance devices, so it's high performance compute. So they tie the CPU and storage together. Mm-hmm. So it's a very strange database cluster, to be honest with you. But okay. Yeah, it's like if you go into a server, you do uptime. It's like 128. Mm-hmm. So I don't know quite how it ties the storage and compute together, but it's supposed to be faster than Oracle. But not convinced. So
I will have a look into this. There may be some suggestions when we get to databases as well, so I will keep that in mind. For now, everyone, we have multiple EC2s, multiple EBS volumes. And sometimes we might need multiple volumes, just like Andrew mentioned, and that is perfectly possible. But could we also have this? Two EC2s talking to one EBS volume. What do we think? We have a few answers in chat. Let's see. The answer is yes, it's possible. However, and there's a lot of howevers, and we're not going to explore this in too much detail. It's a more complex, it's a more specific functionality. It is possible if the EC2s are Nitro-based instances, EBS is provisioned IOPS, they're in the same availability zone, only a certain amount of a certain amount connected, not concurrent access as well. It's a lot of it depends. We call this EBS multi-attach, and it is possible with a lot of limitations. So it's not the general intended design for EBS, but it is possible. So I will link documentation to that. But really, the best way to access in a block level way data, but in a concurrent way and a centralized way, is through a file system, such as Elastic File System, because EFS is just ultimately block level data plus a file system on top to offer that concurrency. And what Elastic File System does is it exposes something that we call mount targets. So multiple units of compute can access a centralized storage location. And that makes EFS a good block way to access centralized data. And because it offers that concurrent level of access, it's able to do so because it has a file system on top of that block level interaction. So this diagram is actually really good here on the cloud storage overview. It shows how block level storage works with the individual parts of data. Likewise, file storage does the same, but it offers, through that additional file system, multiple units of compute to connect to the same storage location. And object level storage just sees the whole object as a whole. Simpler. It's not meant to dive into blocks of data. So we will have a look at that shortly as well. But let's just get file system out of the way, as it's quite a simple one. It just has a few offerings with EFS for Linux-based solutions, so with Linux instances, and FSX is for Windows-based instances or others. FSX is basically a family of 4 offerings. Slides-wise, the next ones relate to S3, but in terms of a narrative, it makes more sense if I showed you file systems here. So I will show this first, and then we'll move over to S3. Like we said, EFS is ideal for that multiple instances, centralized storage solution, actively changing. It's going to expose those mount targets to one or more instances. It's a network endpoint ultimately through which the instance accesses the storage, and it is per usage. So you don't provision a certain size with a file system. You just use as much or as little as you need, and that's what you pay for. It has that elasticity benefit that scales throughput as well. Like we said, it automatically shrinks and grows, and it offers cost optimization because of that. And remember, there's different ones, EFS for Linux or FSX for Windows or other options as well. Really, we don't dive into this too deep. We just offer the possibilities here so you know what to work with. But a much bigger service. Really, one of the largest in terms of possibilities and features and everything is S3, because this is also the absolute first service that we have since we launched AWS in 2006. This is not just a small history fact to it, it will have a technical relevance. Before we dive into S3 though, do we have any questions on the previously addressed concepts? If no questions, give me a quick thumbs up and a +1, please, just to know that we're all okay and it makes sense. That is fantastic, everyone. Thank you very much. That is perfect. Right, everyone. S3 is a solution for object-level storage. It stands for Simple Storage Service, and it can be used for a lot of use cases. It is object-level storage designed to increase agility, reduce cost, and really just accelerate innovation by having quite a bit of flexibility in terms of features. Do remember, please, though, that it does work like this. So it is best used for write once, read many solutions or warm model of data operations. In other words, can you have this as a document that you continuously work with and change? Absolutely. The problem is, if this is a 10 gigabyte file and you make a 1 megabyte change, you pay for the operations with 10.001 gigabyte data. For one operation, you make another operation, depending on how much data you change or use, that's going to be, again, a full request there. So it's not good for continuous changes. If you have images, movies, soundtrack files, PDFs, or archives, backups, and more, these are good use cases for S3. Remember those elastic block store volumes? Well, you can back them up. You can create a snapshot on this snapshot, and this snapshot is actually going to be stored in an S3 bucket. It's not an S3 bucket that you see or manage, but that's where it's stored. So whilst this is block level data, the backup of it is an object in object level storage. That's how databases will work when we get to them shortly as well. So ultimately, everyone, different use cases, but training to that way that the objects that we store in the bucket work as items of data that we shouldn't continuously change. We identify the buckets by a unique host name that includes the bucket name and the S3 service endpoint as well. And we say that the data is stored as objects into S3, a bucket. Now, before we go into securing objects, let's visualize and understand S3 a little bit better here. S3 is a serverless resource. It doesn't live in an availability zone, it lives in a region. So when we put an object into S3, what actually happens behind the scenes is this. That object gets replicated across multiple availability zones as such. but it is within the same region. So we do not take data out of the region by default. It's inside. Can you take it out of a region? Absolutely, but it is a choice. So if you want to perform replication to essentially another region to get this object replicated in another region as such, there we go. That is possible, and we call it cross-region replication. But remember, it is a configuration we have to choose to set up as well. It could be same region replication as well, but more often we use it across regions for disaster recovery or reducing latency to customers around this side of the world as well. So everyone, how much data can we store in S3? Virtually an infinite amount, because it's serverless and because, well, yes, there is a certain amount of physical drives and hardware inside a data center, but we keep adding and growing that number, so ultimately it changes. We don't really put a top limit on how much you can store in S3. So the bucket itself can be virtually unlimited. Individual objects, though, do have a limit, and that limit is 5 terabytes as a maximum. Do you want a larger object? You may have to split it, as in you will definitely have to split it before you move it into S3. So you'd be technically storing 2 different objects. So Pravin is asking a very good question there. It can be a little bit confusing with S3. The question is, isn't S3 global? The simple answer is no, it is not. And I'm really wanting to emphasize that because of the following reason. Data governance, buckets, where the S3 resource lives, is regional. The service is globally accessible. So that's why you may see global at the top, but ultimately a bucket will have a regional endpoint. So if I go to the bucket to an image as well, for example, the endpoint of this bucket, if you check the URL, actually not the URL there, this is because if it's a hosted path URL, but the data location is within a region. So even ultimately through this URL, you are routed to the regional service endpoint of the bucket. That's what we mean, Pravin. It's a globally accessible regional service. A service such as CloudFront, on the other hand, is indeed global. So when we'll see CloudFront later, and I create something like a distribution, later as in tomorrow, nowhere here do I get to choose a region because we're not even using one. We're really using edge locations. So just to give you an example there, Pravin, as to why that difference is there. But absolutely no problem at all. Right. Virtually infinite amount of data, everyone. So let's take that bucket. And let's say we store objects. There we go. There we go. There we go. There we go. Quite a lot of objects. What do we think? Do we access all objects with the same frequency? Are they all just as popular as in day one? Most likely not. With S3, we pay per data per time. So the more data we have, the more we pay over a period of time. So it would be ideal if we can get some cost saving in that area as well. And we can. Because we have different tiers. We have S3 standard, which is the more common one, the most expensive, but the most flexible as well. We won't go through every single detail of the storage tiers because that will be just brain dumping information. We will look at it from an architectural perspective. Again, as always, if you want to learn more, let me know and we can address this in more detail separately, but we will cover it from a more architectural perspective here. S3 standard, most flexible, fewest restrictions, and that comes at the highest price. However, things change as we access data less frequently because the price keeps dropping in this direction. The dollar sign is smaller. If we store data in S3 standard, infrequent access. But we do really mean infrequent access because whilst it's cheaper to store data per unit per time, something happens here. An extra fee is added for retrieving objects. Meaning, if I store an object here in S3 standard infrequent access and I request, the cost here plus the cost here is going to be greater than S3 standard. So we really do mean infrequent access. Longer term, it should be cheaper if you don't request it often enough. You can go even cheaper if you decide to not take advantage of the 3 availability zones. You could say, I want less availability, so I'll go with 1 zone IA. It gets cheaper. But then we really go into the cold storage tiers here, diving into Glacier, which further splits into more categories, instant and flexible, which also splits into 3 categories, but we won't go quite that deep. It does get cheaper per unit per time as we go forward, but there is another difference here. Let me get rid of some of these objects. I've drawn a little bit too many. See, up until Glacier Instant Retrieval, we can download the data, we can initiate the data download within milliseconds, so right away. From flexible retrieval onwards, things change. So there we are, instant retrieval here at the top, meaning I issue the GET request and my data starts downloading. But once we pass this, it may take anywhere from minutes, so let's say 5 minutes, could be 2 or 3, all the way to 48 hours in the absolute longest capability of Deep Archive. So at the longest possible option, it will take you 48 hours not to download, but to initiate the download request. So basically, you hit download, and in 2 days, it actually starts. The benefit is you pay the absolute cheapest rate for a unit per time of storing data. But of course, this is a balance between performance efficiency and cost optimization if we think about the AWS well-architected framework considerations here. So there we go, just a very brief reminder on this guide here. So everyone, this is not multiple buckets this is configuration per object. So it's one object that can be moved to different storage classes or stored as a particular storage tier. So if I show you this in the console, if we go here to S3, so Arslan, deep archive is 12 hours to restore usually, but in bulk retrieval in deep archive, it can be up to 48 hours. So AWS S3, the archive bulk. So there we are. S3 Glacier Deep Archive in the bulk retrieval can be up to 48 hours as well. So it's going to be much cheaper, but much longer. Does that make sense, Arslan?
One of the issues I found with Glacier is when it's not instant access, you've actually got to request each individual file back. I don't know if there's if you're trying to retrieve a backup archive, for example, and you've got to request 10,000 files back, then it's is there an easy way to do that? It's difficult.
So there should be, Andrew, and it's something that we don't technically explore as part of the course, but I will show you really briefly here. If we look at batch operations, you can first inventorize your resources in the S3 bucket. So you would produce an S3 inventory CSV file that is achieved through the inventory feature. So if I load the buckets, I'll choose a bucket. Doesn't matter really which one. Should be in, let's try management. There we are. I would choose an inventory configuration, which gives me a CSV file of the, a manifest JSON actually, of the files that of the object that I asked to be inventorized with various degrees of metadata if I want to. Different elements that I can add here. That inventory I can then reference in batch operations to perform an automated job. So let me just find the manifest object here so we can have a look. There we are. There we are. There we go. And let's see. This one. This is what we could use to restore at a bulk restoration, if you will, or in multiple files. Or we could make it more personalized if we invoke a Lambda function. But there is a built-in integration here, and this is how we could look at that.
Okay, fantastic. Thank you very much. Yeah.
No problem at all. Once you go through that process, you actually get a job report with completion status, an actual report to show what's gone well, what's gone wrong. As you can see, some of them have failed in my case. This was a permission issue, actually. So it's quite a useful tool. And Duncan asking, just out of interest, do we know how Glacier is implemented? What type of storage medium? Duncan, I'm afraid not publicly available information in the sense that S3 works this way because it's serverless. So whatever AWS do to make S3 work this way, it's one of those things that we say it's not something to worry about, or it's not public-facing information because it's abstracted away in that way, Duncan. We can speculate purely because of the retrieval times, isn't it? Had these been tapes in Glacier Instant, well, it would have taken more than minutes to retrieve. So we can speculate what could be there, but not as far as I know. Being some
mainframe guy, so I'm familiar with tapes, and I used to be a mainframe guy, so I'm familiar with working with tapes and long retrieval times. So it was just out of interest, yeah. Thanks.
Of course, no, that makes perfect sense. And I, whilst rarely I do get that question sometimes, it's I can't confirm nor deny. Let's put it that way, Duncan, if that makes sense. But it is meant to be highly performant, if that helps, as we can see. That is perfect. I can see the thumbs ups. That is perfect. Thank you. So everyone, we were having a look at uploading an object to see how that would look like. So in a bucket that I have, and by the way, if I create a bucket, I am choosing a region here. But when I have a bucket, if I upload an object, and I'll just do a simple drag and drop here, that also works. I could click upload, but drag and drop also works. Please notice at the object level, I am choosing the storage class. So one of these ones that we have here, including something called reduce redundancy, we don't talk or recommend this one. So that's towards deprecation. So the data tiers that we talked about, everyone, are per object. And again, virtually infinite amount of data, we might need to manage this in a more, well, manageable way. So we can configure an automated way to move the data into lower storage classes via something called lifecycle rules. But this is manually manageable, and it only goes in one direction. If you want dual direction movement of data, both lower and higher, depending on live monitoring of frequency of access to these objects, we can use S3 intelligent tiering. This is a machine learning solution which will have a fee for that machine learning algorithm that looks at the frequency of access of objects and decides based on those whether the object should stay in standard or be moved to infrequent access or even archival solutions, depending on how often and how frequently it's been accessed. Ultimately, even though you pay a little bit extra for it, overall it should offset your bill to a more cost-optimized one. So everyone, this is S3 from some functionality perspectives, and we do have a few more to look at, including securing objects, but we have explored quite a bit of it so far. Is everybody happy to take a coffee break here before we dive into security? And then when we're back, we'll finalize S3 and move into databases? If anybody has any questions as well, please do let me know. I'm going to give people a few seconds here. But it seems like we should be okay. So everyone, let's head over for a quick coffee break. And when we're back, we'll finalize S3 and go for databases next. Enjoy your break, everyone. I'll see you shortly. Welcome back, everyone. Hopefully we are all back from a short but hopefully relaxing coffee break. Next up, we will look at S3 security, and then we will move over to databases. Now, if you're following along with the slides, you will have noticed we are carrying on through the slide content, through different mediums of presenting it, but we will not have covered, and we won't today, right now, the data migration tools or elements like storage gateway. We will do that tomorrow when we review this as well, in the interest of time. So just to reassure everyone that we will cover all the content, but we are adjusting it to the class as well as we go through it. If anybody feels we should do it differently or would like a different approach, do let me know, please. As always, I'm here to give you the most tailored approach as possible. I am also aware we're going at quite a brisk pace through the content because it's a lot. So if at any point, I always suggest, we can explore more complex topics separately. Likewise, please let me know if you'd like me to reiterate entry-level topics as well. So maybe during a lab time, you would like to go in a separate private room to understand a little bit better object versus block level storage. Any level, any question is welcome. And on that note, let's talk about securing objects. The fact that S3 came about in 2006, and it was the first AWS service, it's not just a history lesson. It means IAM came later, so we didn't actually have resource policies. We actually had access control lists, but we won't actually spend too much time on these because they're not recommended anymore. Quite simply, they are the old way of doing things, and they're not as granular. You can provide access to users, to accounts as well, and at object level, but not really as detailed as bucket or resource-based policies. These are the granular, recommended way of giving access to S3 related resources. And much like we've explored in IAM in a lot of depth, we have effect, action, and resource to define whether we allow or not the API calls on the bucket and maybe its subsequent folders or prefixes, more specifically known. And of course, we mention who is the beneficiary of that access. Who is the principal? Now, this is a little bit extra here, but I think it's a very useful and important one. S3, virtually infinite amount of storage, and we can protect it with a resource-based policy. So resource policy. But a bucket being virtually infinite could have a lot of objects for different types of users. Maybe a developer team 1, maybe an auditing team, and a management team as well. Multiple different users in these teams with even them varied levels of access. the thing is, if we wrote all of this in a resource-based policy, I would have to define team 1, team 2, team 3, different conditions, and I simply don't have enough room because the maximum size of a policy can be 20 kilobytes. Not enough. So what we can do is open up other doors into the bucket. They're not truly doors, of course. They are what we call S3 access points. And these S3 access points are additional points of access into the same bucket. In other words, you can attach resource-based policies to those access points because they're just additional endpoints. Each of these resource-based policies having their own 20 kilobyte limit, and this way we can scale the permissions side of things as well as keeping things more granular, because you give to team number 1 just the endpoint address of this access point, and you give them access only to this much data. Team number 2, we give them access to this access point, to this much data. Team number 3, this access point, and you know what? They could have access as an allow all, so to all the data. It's still the same bucket at the end of the day. It's just a different door, a different endpoint to that bucket. Does this make sense so far, everyone, with S3 access points? Because it's quite an important one, especially as it ties into the next explanation.
I've never come across those before. I mean, we've a proliferation of buckets. We've got about 3,000 plus buckets. And I think it's very hard to manage them. And I think if we used access points, we could reduce that hugely. Yeah.
Andrew, there is a very good point there. Yeah. Because, and I will show this again recurrently, if we check service quotas, I think you may have requested a limit increase on the buckets. By default, it's about 100, if I'm not mistaken. Buckets have a limitation. You can increase how many you have, that's fine. But as I'm sure Andrew will be able to attest, when you create the bucket, it has to have a unique name, not in your account, not in your region, but across everybody's account and every single region. Being accessed over DNS, as a DNS-based endpoint, it means this URL has to be unique. Meaning, if I want to create a bucket called demo, what are the chances of this to succeed? Virtually 0. Let's try. Yeah, that didn't work. But I have a foolproof plan. Demo 2. This doesn't work. And you know why it doesn't work, actually? For the first time ever, last month, I was able to actually get it. I was very surprised during the course as well, but Demo 2 is actually mine now. So Demo 3, not Demo 4, 5, of course, doesn't quite work. As best practice, we should give a name that is logical for us. Demo could work, but then programmatically append a random string, and this can work. We can talk more about the programmatic side of things as well, but it's beyond the scope of our course. So Andrew, absolutely, can be a little bit difficult to manage 3,000 buckets when we can manage access points as well. They will still have different endpoints. So notice this. This is the bucket. It has one main endpoint, the virtual hosted URL endpoint, as well. Let's see, let's go to this one, for example. So the endpoint of the bucket will be this. But access points will have a different endpoint. So let's see. if I check the access point, I can access the same data, and notice the URL. Can you see this, Andrew? So it is a different DNS name altogether, but it will point ultimately to the same bucket. Exactly right, Anthony. Once you delete the bucket, the name becomes available. So I'm sure you can appreciate I probably won't delete demo2 too soon. So does that make sense, Andrew, as well? It's a different entry, but in the same bucket. So if you manage your data centrally in the bucket, absolutely that hopefully can help, because access points, in terms of limits, we have 10,000, and that is an increasable limit. Very easy to increase.
Perfect, thank you. Yep.
No problem at all. You just issue a quota request increase, send it across, and eventually AWS will respond, sometimes within hours, even minutes, depends on the quota increase. It's not an immediate response though, so that depends. With so many possibilities of giving access though, it's important that we are able to drill down and close them off if anything breaks. So that's where S3 block public access comes into play. This is a catch-all option where you disable access through ACLs new or old, through bucket policies and access points new or old. It's like a catch-all, deny public access. And like we said, access points as well, but we've shown this in the diagram also. Not going into too much depth into the next one, but we can also encrypt our objects as well. Not the bucket itself, but rather the objects. And now this one is applied by default. It didn't always used to be the case, but encrypting objects on the server side, so in S3, with S3 managed keys, happens by default. And really the difference here is the amount of effort, but also the control. Because quite simply, if you encrypt data, a key must exist. Who handles that key? S3 in S3 managed keys, so you don't even see it, manage it, touch it, rotate it, or anything. Or you do that on AWS's KMS service, where you have some degree of control, but also some degree of comfort. It's abstracted away. Or you might have your own hardware security module where you produce your own keys, take it to AWS, and encrypt the data there. But that gives you the most effort, also the most level of control. So again, it's a balance that we're trading level of control with a degree of abstraction. So everyone, a couple of more elements here regarding storing objects, and that is the storage classes that we talked about. So we won't spend too much time on these slides. Just remember, there's a lot of options, with Glacier Deep Archive being the lowest cost but the longest retrieval time, and S3 Standard being the most frequent and the most flexible one as well. Intelligent tiering being able to move data between different storage classes as well, and Glacier offering various benefits depending on the Glacier option also. Like we said, there's also flexible retrieval that can range from minutes to hours. You have quite a lot of choice with the Glacier offerings. Regardless though, all of them are still object-level storage. So when you upload a new version, you lose the previous on a default configuration. But sometimes we might want to actually keep both versions. And that is possible if you enable versioning. Just remember though, you pay for all the data stored in that case. So the data of your first version, 10 gigabytes and 10.001 gigabytes, is what you pay for in total for one single object. Because versioning keeps all the previous data that we've had since we enabled versioning. And then if you want to delete versions, you have to specify the exact version ID. And to delete the objects, you have to delete every single version. Now, infinite amount of objects. This can get a little bit out of hand. You can get version 5, 6, 7, 8, 9, 10, 4, 3, 2, 1. All of these accumulating costs, and maybe we don't want that. With lifecycle rules, we can actually control the amount of versions we have as well, because in lifecycle rules that I will show shortly, there we are, lifecycle rules, I can create a rule to say demo rule permanently delete non-current versions of objects or move between storage classes, work with the versions themselves. It's quite granular, it's quite flexible as well. And we choose after 9 days, I want to keep the latest 3 versions. So in my example here, after 9 days, all of these get deleted. So have just version 10, 9, and 8. So we have options here as well in terms of how we handle this aspect of data. So everyone, S3 is really feature rich. I will mention a couple of other features once we go through the review as well. But in the interest of time, I think we've covered quite a bit of it as well to be able to do the lab and understand the topic. Remember, you can also automate reactions to S3. Ultimately, virtually infinite amount of data. When we work with the data, we might want to do something with it, such as apply a watermark to that JPEG image. Maybe this is a website for graphics design. So maybe we want, when a new JPEG image is uploaded, for the graphics designer's watermark to be applied so the image is not stolen, or we make it a thumbnail so we resize it. That's another option. We can configure event notifications as a way to say, right, upload, deletion, copy on an object happens, trigger a Lambda function, or put a message in an SQS queue. So it is something we can configure as well to automate reactions to our work with S3. So from management, from properties, event notifications, and we can choose quite a few API calls to respond to with a Lambda, SNS, or SQS queue. So everyone, before we move over and talk about databases as well, do we have any questions on any of the elements that we talked about regarding different storage services with EBS, S3, file systems? This will be a tomorrow topic as we go through the review. So any questions, everyone, or are we okay? I see a few sporadic thumbs ups, just giving everyone a chance here to catch their breath, as well as probably typing your question if there is any. Okay, so Bhavdeep, if we have an order where we have multiple number of products, but the fail happened while processing from a third party, and it can happen anytime between 5 minutes to 40 minutes, this information needs to be shared as a report other morning. We cannot store this info in a database. So that is quite a lot to unpack there, Bhavdeep.
Yeah, means in short term, it's like if if I generated an order and it has got multiple in the single order, if I've got multiple items associated and those item needs to be somewhere validated in some third-party tool, and that validation or information of that validation is not in our hand. It's not like I hold that information and it can come in any time between, like it can be an hour also. Like it is not with me. So it depends.
Yeah.
They will be processing an order with that product, again the order with the second product, and then simultaneously, like if there are 5 products, it will be calling 5 times. I can't store those information where it has been failed or for which it has been failed, but I need to have, like I have that information that okay, it has failed. So now I need to provide a report saying that okay, it has failed, but for what product it has failed is something which I have to do.
Of
So
course.
in this regard, like since I cannot do it anything to my database right now because it's an existing and the indexing and everything needs to be updated and it can have its own performance impact analysis needs to be done. So what would be the best way to use, like is it an S3 bucket where I can put it those object and keep updating based upon whenever the failure happened, or should I go for something else?
So, Bhavdeep, that is a very, very complex question. I'm happy to answer it, but are you happy for us to take it separately? Otherwise, it would take us a very good 15 minutes, I would say, to properly look at it.
Yeah, fine.
So are you happy to do that, Bhavdeep, so we don't steer it too far away?
Yeah, it's fine.
Okay, no problem at all. So we will cover for the next half an hour databases, and then we will have a look at your question as well, Bhavdeep.
Thank you.
No problem at all. So everyone, let's have a look here. Not sure why my PowerPoint keeps going to the wrong screen, but I suppose we can work with that. There we are. Let's also have a look at databases so we understand what we're going to be looking into the lab next. So, do you know which databases you have in your workloads? Do you have relational, non-relational? We have heard a few inputs so far. Do you use caching at all? So, what are some inputs here? Database caching, sometimes just caching alone as well, or actually, no, just non-relational and caching. Migration tools, have I seen no migration tools, okay. But basically relational, non-relational, and maybe optionally some caching, essentially. That is perfect, everyone. That's exactly what we're going to look at with this module, talking about RDS as the relational kind, DynamoDB as the key value non-relational kind, some caching solutions, and migration tools. These we might cover after lunch though, so we give you the required information for the lab as well. On AWS, we have quite a few database options. Obviously, we won't explore all of them in this course, otherwise you would turn into a data analytics or big data course. We will have a look at the relational kind with AWS's own Aurora and DynamoDB for the non-relational key value solution. A touch base on Elasticache and a very brief mention of Redshift, but there is a lot more to choose from, such as TimeStream, Quantum Ledger, and more types of databases, Graph as well. What we will focus on is the relational versus non-relational one. RDS here versus DynamoDB here, mainly, of course. Relational databases require more predictability, more rigidity, or a fixed schema. We need to be able to link tables together via indexes and to be able to relate data with each other. That requires tables to be more fixed, not as much flexibility. You store data in columns and rows, and they are usually instance-based. So if I bring this lower, actually I will use this one because it's going to be better. There we go. A relational database, an RDS instance, if you will look and live in a subnet. So tell me, everyone, if this happens, this is an incomplete solution, of course, but we are keeping it simple for concept purposes. Front-end data layer. Can I still access my website? And yes, we have an internet gateway. Again, of course, some technologies are missing, but can we still access our website? What do we think? So perhaps we might still do. Our EC2s hosting the website, we might still access it. Ryan, absolutely right, but not the data. So RDS could be improved there, but it's not quite yet. So if this was amazon.co.uk, we could access it, but not place any orders because there's no product list to choose from. There's no data populated because the database layer is gone. We will check how we can build availability into this one in the next module after lunch, but it's also important that we do it for the databases as well. So this right here is an RDS primary instance. And as a primary instance, this one supports both reads and writes as well, of course. Now, as we've seen, a failure in the availability zone would take it down. And it's quite difficult to have multi-read, multi-write usually with relational databases. It's a complex thing to achieve. So what we can do, however, is this. Is we can perform a replication, but to a multi-AZ standby. You can't read, you can't write to this. It's a multi-AZ standby. It is something we have to choose to have. And what happens here is, if this primary fails, then all requests get rerouted automatically to the secondary because this gets promoted to the new primary. So this happens seamlessly behind the scenes without us having to do anything apart from choosing to have it. It does take a few seconds, but it does happen seamlessly. And then a new secondary appears in not the same availability zone as the new primary. So the secondary could be here, could be here. This is how we can increase availability. It doesn't impact performance though. Performance is all handled by the primary. You want more performance, you need a bigger primary. So you would need to basically scale vertically. Vertical scaling, basically making the instance larger. Because the instance, it's actually an instance. I'm not going to call it an EC2, but it is a virtualized slice of hardware that is called an instance. It's an instance-based that has a database engine installed. It's like a managed EC2, if you will. So if I create the database in RDS, you can see here, I can choose one of these 6 engines, 5 of them being integrations, And Aurora, compatible with MySQL and Postgres, is AWS's own product. But these are instances. If I go a little bit lower, you will see I can choose an R6G to X large, X2G 12X large, and more. Different options, including T's as well. So T instances, T3 large, T4G medium, and so on. Different engines, different capabilities. And notice how we choose whether we want a single instance or a multi-AZ one. I go with an earlier version though. There we are. This is how we implement that high availability at the flick of a switch, if you will. It's an API call to say, I want this dual representation, active, passive, if you will. But what is the most common operation to a database? Between reads and writes, what will happen the most? Normally reads, absolutely. Let's say about 90%, 10%. It does depend, of course, but as a rule of thumb. Caching, Praveen, that depends whether you do want or not caching, so that depends. So it's a little bit difficult to have multiple primaries, multi-read, multi-write solution. In some cases, it's possible, but it's not the given rule, basically. We can, however, offload some of the reads. So what we can do is create replicas that we call read replicas. And this read replica is an asynchronous replication of the primary for the purpose of offloading some of those reads from it, because ultimately this instance has CPU and memory which are being utilized when we read and write. So might as well take some of that burden off. And the cool thing about it is you can even take read replicas in other regions for cross-region read replication here. Okay, that is not a good sign there. All right, I think we're having an issue here with this PowerPoint. It seems to have crashed a bit, so let's do this here. Let's open a new one. There we are. There we are. There we go. So this, of course, being cross-region in that respect. So this is possible as well. Now, it does have a top limit. The primary instance can only get so big. In the case of regular engines here on RDS, you could get up to 64 terabytes, I believe, in storage, unless this has been updated recently. There we go. This is a little bit lower, actually. Let's see. Just 6 terabytes here. Okay, let's go with a newer engine. Interesting. Because it's a T2 micro, my apologies. There we are, about 65 terabytes of storage. But if you choose something like Aurora, this can actually get bigger. In the instance-based, it can get up to 128 terabytes, so it's double. It's quoted to be 5 times more performant than MySQL, 3 times more than Postgres, and something that only Aurora can do is be serverless. So Aurora can actually function as a serverless solution here. Overall, Aurora, being AWS's own solution, is more performant, more capable, and more flexible overall in that respect. If we check the slides as well, and we have a quick look at Aurora, we will also see that Aurora replicates the data layer in multiple copies across a region, so that if a failure happens and a failover has to occur to a Aurora replica, that takes the data from the data side of the instance much quicker. So they are quicker and more performant in that respect. Like we said, there is a serverless option as well. So everyone, any questions here on databases before we have a look at a few other elements such as DynamoDB? Caching will be after lunch. But do we have... Yep.
Question, Stephen. So, if you go back to the portal, I want to understand which database supports multi-AZ. Is it all of them, like MySQL, RDS, DynamoDB, they all support it? Or is it limited to, is it like supporting all of them, the multi-AZ deployment, or is it only not supported to certain ones?
So I believe, Arslan, Microsoft SQL actually might have a limitation to the multi-AZ. Generally, they should all support a form of multi-AZ replication, but I think Microsoft SQL doesn't quite have customization.
I think it also depends upon their license, like number of license you own for that.
That could be a case as well, but it's a bit, so Microsoft SQL is not, it's just an integration, for example, not that deeply deeply embedded, if you will. So let's see, the enterprise one, standard, we could have a look, but I believe this Microsoft SQL is more limited in those options. Oracle should be able to, if I remember correctly. So let's check this one. It doesn't seem like it actually. So Oracle as well. The others, they should all be possible. So MariaDB, for example, should offer multi-AZ. Let's check. Might depend on the engine, version, optimized writes. So they have a few differences here. Doesn't seem like MariaDB either. I was under the impression they supported, but Postgres, MySQL, and Aurora, they will all support multi-AZ in this respect. And with the newest ones, they actually have a multi-AZ database cluster, but that's with the newer versions where you can do reads and writes as well, to up to 2 instances extra. So if I choose an older engine here, there we go. It's not available. So this is more in a newer feature, but it's only for more specific versions. Does that make sense, Arslan?
Yeah, it does. Thank you, it does. Yeah.
No problem at all. I would say if you're using Microsoft SQL Server and Microsoft integrations, also have looked at Managed Active Directory or Managed AD, Directory Service. Keeps changing the name a bit here and there. For trivia points, this is actually the service with the longest AWS name, if anything. AWS Managed Microsoft Active Directory, and even longer, I believe. This is a way to integrate with on-premise Active Directory or set up your own in the cloud. This is to further build that bridge if you need to. So for the person that's messaged privately, what time do we finish today? Just like yesterday, I will plan to finish the teaching around 3:30 British Standard Time to give you time to do the lab on your own time or enjoy an early afternoon as well. So the same kind of thought process there. Yesterday we did the same at 4:30. We'll do today as well. And Neptune, Jacek, I would have to check actually for Neptune. I haven't worked with Neptune in detail myself. I believe it is instance-based, but I haven't worked with it myself in that respect. So we could have a quick look. It seems to be serverless as well. There we are. It is graph-based, absolutely. Let's see. There we are. Multi-AZ deployment. So create a read replica for that purpose. Would it fail over automatically? Again, something we can check. Will automatically fail over. There we are. Absolutely. So it seems like it does support that in the instance-based scenario for the graph database. But if you want more information on this, I will do some research, as my expertise doesn't cover deeply data, big data and databases solutions to a deep extent.
Okay.
However, does it make sense, Jacek?
Yeah. Thank you.
No problem at all. Okay, so everyone, let's cover DynamoDB as well. In this course, it's again really just high level. In developing on AWS, we cover this for more than 2 hours. So just to give you a flavor of the difference, today we're going to cover it for about 5 to 10 minutes because it's a different focus as well. So everyone, we've seen RDS and how many things we have to configure. It's instance-based, so we have to configure the network, the security groups, the instance size, the instance type, kind of like with the EC2, plus other elements such as, let's go to RDS. So such as encryption, backup, retention, automated backups, manual backups if you want to. So quite a few things. Replication as well, engine versions, and all of those things. There we are. Quite a few elements to configure. Subnet groups, IAM database authentication, and more. There's quite a bit. DynamoDB. On the other hand, you create a table, you give the table a name, you populate something called a partition key, and then a sort key, so already starting to work with the data structure here. We leave the defaults, which we could configure if you want to, but much like with Lambda, we can also go straight ahead and in 3, 2, 1, 0 and a half, there we go, we have the table to which we can already start populating records. So I could go ahead here, create item, and I could say author 1, book 1, and create this item. But you know what? Author 2, book 5, I know how many pages it has. It has 50 pages. But also, author 3, book 8, I don't know how many pages it has, but I know the price, which is $4. It's a cheap book. And I also have author 1 has published another book, book 2. And for this one, they've given all the details, pages, 599 pages. They've given the price as well, $9, bit more expensive book. And they've given a answer to whether or not it contains dragons. It's a sci-fi, it's a fantasy book, so yes, it does contain dragons. Notice the flexibility here. Some records have attributes, some don't have all the attributes, some mention dragons, some not, some have pages, some have price. It's meant for flexibility, and it's meant for performance. One thing we do need to have is this primary key here. We don't really go into the depth of why too much in this course. It's kept still fairly high level. It's based on the fact that we refer there to a partition. So let's have a look at it here. Let's have ourselves a region with some availability zones. As well. There we go. And DynamoDB, kind of like S3, lives here. And when we store data in DynamoDB, technically this is what happens. We doesn't go into a particular one single table. Really, the table is really just for us as humans to understand it a little bit better. But what happens actually is there's a set of partitions behind the scenes. And when we populate something like item, or you know what, author, let's call it author 1, it actually gets replicated across multiple physical distinct partitions within the region. That is how DynamoDB stores the data across partitions, and we see it in the form of a table more for our ease of understanding it. Really, it's not this. It's not a table. It's really just a JSON document. Imagine this being the element stored on that partition. So I take it here. This is the document. There we go. This is the element stored on this partition. My apologies, I can see yellow is a bad choice of color. That is what's stored on the partition, and the way DynamoDB achieves millisecond level performance is because it is able to pinpoint the exact partition to retrieve data from when you make a query because of that partition key. Have you noticed how I always populated author? Well, I have to. In my database here, author is really the way I identify those partitions. It is the attribute of my partition key. It's the data that I give DynamoDB when I want to retrieve a record. I say, give me author 1, and it goes straight to the author 1 partitions, and it gives me the data for author 1. Now, what if you have millions of authors and you don't know the author name? You might need to scan. You might need to get a lot of performance. So how do I get more DynamoDB? Storage-wise, virtually infinite, like S3. There's nothing to manage there. There is some item size maximum limit, so this can only be 400 kilobytes, but this is more technical detail here. So everyone, what do we think I can scale of DynamoDB if size is not one of them? So I can't make it bigger or smaller. Then how can I influence it, do you think? It's still a database. That is a hint. Andrew refers to indexes. It does support secondary indexes. We can explore that separately, Andrew, but I'm afraid that's not what we mean by scaling it. That can help with more clever interaction with DynamoDB, better structuring if we need that. But it's not the scalability aspect. What actions do we take against DynamoDB? Again, the most common ones. Being a database. So just the actions themselves. Reads and writes. And on DynamoDB specifically, we actually request more reads or writes. We call them read capacity units and write capacity units. And we can choose more or fewer. I can quite literally get this. More reads, writes. I can even get them separate. I don't have to get writes if I'm only reading data. There is a specific calculation with reads and writes we will look at after the break, but the idea is it's serverless. We can choose to customize, and we can choose whether I want as little as 1 read capacity unit or as much as 6 million read capacity units. I can calculate how many I might need with a very helpful capacity calculator here. So I could choose my average item size is 3 kilobytes. I need about 8 reads per second, and it gives me the recommendations. Or I could just say, I don't want to worry about it. I go on demand, and AWS gives me as many or as few read-write capacity units per second. It is meant for performance, so much so that we use it for Prime Day as well. So AWS Amazon Prime Day 2023. DynamoDB, at the peak of our discount days on Amazon website, offered 126 million requests per second with single-digit millisecond response times. So it's really, really, really meant for performance there. I have noticed, I think we have some hand raised, so I suspect someone would like to ask a question, if I'm not mistaken.
Yeah, sorry, it was me, Stephen. I was just trying to understand, the Amazon Aurora database that we mentioned earlier.
Yep.
That's also serverless. So I was trying to see for the read-write capacity, is it kind of same functionality for read-write in the read-write terms? Because just to try and say what's the best use case if we have those two in place. Just exam kind of scenario, just trying to get my brain on that.
Of course, Arslan, I'll be more than happy to answer that. Simply because of time, are you happy for me, Arslan, to just give everyone the chance to go for a lunch?
Sure.
I will address that question and the other more in-depth questions that we had, but just to give everyone the flexibility here in that case.
Yep.
Thank you very much, Arslan. So everyone, we have looked at the 2 main database solutions that we'll need to cover lab number 3. So let me give you the class link and enable the lab for you. Let's do manage labs. Let's do this as well. Lab 3. There we are. You should have it available now. So everyone, in lab number 3, you will work with an Aurora database, and you will be building it as well to work with instances in private subnets. You will essentially install the engine. You will work with a load balancer, but we will learn about this after lunch, and then you will test some connectivity aspects. And you have the lab available and ready to be launched. We will go for lunch and lab. I will be here all the way throughout the next, I'm going to put it as an hour and 45 minutes, so there's plenty of time. And back at 2:30, I believe that takes us to British Standard Time. So let's say back at 2:30 BST. Lab and lunch. And let's put a timer as well. because the lab should be a little bit longer. Let's check this also. And I am aware you will need a coffee break as well. So best to have that time there for flexibility. There we go. Perfect. So everyone, hope you enjoy your lunch. Hope you enjoyed the lab. Remember, I will be here all the way throughout that timer. If anybody needs any help or extra questions, just like we're about to answer now as well. Enjoy your lunch, everyone. I will now go ahead and answer some of those extra learning questions as well. Absolutely, Nikos. We will have a look at those as well. Perfectly welcome. So let's take it in order. Not really a FIFO order, if you will. Arslan, just because yours was the most fresh, if you will. Differences between Aurora serverless and DynamoDB. So, first off, Arslan, Aurora is SQL. So it lends itself to that structured schema and fixed schema. In terms of serverless, all we're really doing is controlling the compute layer closer. So if we look into the console, Aurora serverless is not handled with read-write capacity units, but rather something that's called Aurora capacity units. So if we go to databases and we create a database, let's go to Aurora. And I will look at the instance base first. So we have different instances, much like EC2's here, Arslan, yes?
Yes.
I can change these after I launch my Aurora database, but I'd have to stop it, change the instance type, restart it as well. Bit of a process. It can be done more efficient. So if I choose serverless, it's just not me going through that process. It's AWS saying, hey, we can handle the hardware of the compute much, much more precise. So we can give you 2 gigabytes of memory, or 4 or 8 or 18, depending on how many Aurora capacity units you're getting. It's like saying flip the switch between a T2 micro, T4 large, M5 medium, M4 small at quite quickly, rather than stop, change, start. So Aurora capacity units really just define a different slice of compute that can be allocated much more dynamically. Does that make sense, Arslan?
Yeah, it makes sense to me now. So as you said, right, DynamoDB is more about read and write, but Aurora serverless is more about compute units. See it that way. So if anything, is there anything about compute units in the exam, that would be Aurora. Anything which is read and write and traditional and not traditional database. So outlined that way.
Exactly. And DynamoDB is meant for really extreme performance. No query should take longer than a second. Otherwise, you would just fail. It's meant for that speed of requests. With Aurora, it will be fast, but it's not meant for that kind of speed, if you will. With DynamoDB, you can get that speed because you can give that many capacity units at a more technical level. DynamoDB has 1 kilobyte of data to 1 WCU and 4 kilobytes of data to 1 RCU in strong consistency fashion, or half an RCU in eventual consistency fashion, meaning you have to read 27 kilobytes of data. You need 27 to write, you need 27 WCUs, 7 RCUs in strong consistency, or 3.5 RCUs in eventual consistency. Does that make sense, Arslan, how we look at it at DynamoDB level? We want this sub-second, so that's how much capacity we need to allocate for that query or scan. That is perfect. I can see the thumbs up. That is fantastic. Jacek, you don't present a DynamoDB item as a JSON string. It is a JSON document. It's not just a JSON string. It's strings, numbers, Boolean figures, maps, lists, and a couple more options as well. So there are a few data types there. So if we look at an item, there we are. We can have quite a few data types, binary, number set as well. But the whole information is a JSON document. Does that make sense, Jacek?
Yes. Oh, okay. Oh, cool. Yeah, thank you.
No problem at all. Let's see. We had a person message me privately for the tablet that I'm using. Are you still there by any chance? If yes, I have pasted it in chat in case anybody else is interested in the graphics tablet that I'm using. I have pasted it in chat as well. Okay. So we had a few more questions there. We had... So can you hear me, Bhavdeep? Are you there? All right. Let's see. I think Andrew as well. Are you there as well?
Yeah.
So, Andrew, are you happy for me to give you a bit more insight on Control Tower now, or would you like later?
Sure. That's good. Yeah.
Okay. So, Control Tower. If we have a look at it.
I think Joe was interested in that too. Joe, were you on?
Joseph, isn't it?
Yeah,
Joseph,
yeah.
Okay, that is perfect. So we're all here. There we are. So Control Tower is really just a tool encompassing more services. It's a tool that was born out of best practice, best practice guidelines and practices. And what we do is we set up something called a landing zone, and that really creates a sort of organizational structure where, if I show you in, let me take this away from here. We have some accounts created for me. One of them is a security account. This is an account from where I can access other accounts with cross-account access roles and those kind of elements. It leverages IAM Identity Center to do that. And I have a log. Sorry, these the organizational units. This is the security account for that. And it will also contain logs to centralize logs from all other accounts. So if we think about our if we think about our AWS accounts, so let's give some users. Really unfortunate, my other paint solution actually crashed, so I think that might be lost. But luckily I should be able to do this fairly quickly. There we are, some IAM groups. There we go. Some resources also. And other AWS accounts. an organization, as best practice, it usually is to configure one of these accounts as your log account. So logs can be centrally managed from all of your accounts into that one. In this account, we will have a multi-account trail from CloudTrail to ingest all of those API-related logs. Other logs taken through config, others in CloudWatch logs as well, and they will all go to CloudWatch logs altogether. So this is the purpose of this account, and Control Tower gives that, sets that up for you as well. There is the root account, the management account of your organization as well, and a sandbox account for testing and demo purposing as well. This is actually, so this one I created through Control Tower, that is possible. This one I brought in. So you can also bring in an existing account and integrate it. Besides that, you can establish controls, previously called guardrails. So if we check here, there are 3 types of controls: proactive, preventive, and detective. Preventive are really nothing more than SCPs, and they can be things like, well, these are quite complex. I'll exemplify a simpler one. Let's say we have a control. So this is Control Tower here. Control Tower. We can have controls, which is really just an SCP, which can say deny log account. So we can explicitly deny access to the log account unless you are a specific security admin, for example. So we can ensure nobody can tamper with these logs without explicit approval. There is a deny. There is one that should refer to not being able to turn off logging. So if I look up CloudTrail, we have proactive, preventive, validation, enable. There we are. So this one, enable in all regions. Let's check this one. I think this is the one we're looking for. Basically, someone malicious could hold logging, and this control here, which is based on a service control policy of organizations. Let's see. Just trying to get to the actual, there we go, to the actual policy. Might mean I might not have access to it from here, but I'm confident that's what, oh, there we go. There we exactly. Can you see this here, Andrew and Joseph? Deny, delete the trail, so don't stop logging, basically. And it should be in the, okay, so it doesn't mention the account, but it says unless you are the principal ARN, where you're specifically Control Tower. Now, we might want to take actions that, so we might want to be allowed to take actions, but not to full extent. So I might want to allow customers to launch, so my employees to launch EC2s. But how many EC2s could they launch if I allow that action? 65,000 per VPC. That's how many private IPs we have. That's how many EC2s I could, in theory, launch. There are some limits before that, but still tens of thousands. I can't control in a policy the amount. But what I can do is this. I can use detective rules which say, has this changed? Have we gone beyond a certain configuration element? Has there been a volume launched that's not encrypted? So is anything out of the configuration that we've asked for? Detective rules use config underlining to check for the configuration settings of a resource, be it API, gateway, EC2s, or others. There we are. Is SSH allowed unrestricted from the internet? This is a very permissive and unsecure rule, so we won't deny it in case there is a particular requirement for it. But if someone does launch one of these EC2s as such, where was it? Let's go with this one. We've changed this to an EBS one, but the idea is, if someone launches that, we will. This is the definition, the code definition of that rule. We will check whether it satisfies the configuration or not, and based on that, we can get alerts and configure automated actions. So ultimately, these will be. So one of these rules, for example. Let's see, not severity. Let's have a look. We have released an implementation, not this one. Basically, they can go into a response state or not in that respect. So whether they've been breached or not in that respect. So you could get alerts and you could automate actions based on that. This is more for the governance side of things, but for automation, this is the cool part about Control Tower. It's like a vending machine of accounts, because look what you can do. You can automate the creation of multiple accounts, and while I can't confirm or deny, what does this remind you of? Multiple, identical accounts with resources with really tight controls in place.
It's like a big AMI, isn't it? So.
Even more than the AMIs, it's something you've all done already yesterday.
So it's just creating the whole VPCs and everything.
Absolutely. VPCs, EC2s, how many EC2s you can launch, which ones.
Yep.
So the labs, for example, that could be a solution that's handled by Control Tower. Now, I'm only speculating since we're in an architecting course, but I can't confirm or deny that, as I'm not part of the team, of course, that builds the labs. But does it make a bit more sense how that can work?
Yeah, I'm thinking we have to configure new accounts fairly regularly for different teams, new developers, new projects, whatever. And I'm thinking of if we created the odd S3 bucket, the access policies to those buckets, it'd be really quick. I think it'd be useful.
Absolutely.
Yeah.
And as you create new accounts for those new teams, I suspect they will need certain resources and limitations on them, isn't it? So Control Tower keeps that governance through the controls that I've shown here. And the account factory will leverage a combination of systems manager, CloudFormation, stack sets as well.
One question around CloudFormation, then, because we're a Terraform house. That's our standard development tool, which I think causes problems sometimes. But can you integrate Terraform into Control Tower?
That is a good question. I would have to check, to be perfectly honest with you, Andrew. Let's have a look. So just wanted to see here. It's going to be quite a bit of work, of course, to set up the whole multi-account structure here, but we can configure this customization, this automation. This is ultimately One of the ways we'll integrate CloudFormation. Service Catalog is just a user-friendly way to use CloudFormation. It's basically CloudFormation templates packaged nicely and put into a catalog, so an end user can just pick and select what they want. That is Service Catalog, and this is how we can produce that multi-account structure here. Does it work with Terraform? Let's have a look. Control tower with Terraform. It seems like there should be some capabilities here. So by simply skimming this, of course, skim reading this, what I suspect happens here is the following. What we're doing is not using Terraform in Control Tower, but rather using Terraform to do the whole work. And that's fine. It seems we are setting up Control Tower with the controls, the landing zone, and everything. And as part of that, CloudFormation. So ultimately, you're just adding a layer on top of everything I have shown by defining it in Terraform's language. I want to say HCL, the language for Terraform, if I'm not mistaken.
I'm not quite there yet with Terraform, so Joseph will answer that one.
What was the question? Sorry.
I was just trying to remember. I think the language for Terraform, HCL, if I'm not mistaken.
Yes, that's right. Yeah.
There we are. So we can define a control tower in HCL and take it from there to essentially. Oh, where was the article? There we are. Essentially to define the whole control tower configuration.
Okay. Yeah, well, I've read that one. Yeah.
Anything else that I can help with control tower?
No, I think that was great for me.
Me too. That was good. Thanks.
No problem at all. It is a pretty big topic to dive into, but it's a pretty interesting one as well. All right. Thank you, Andrew. Thank you, Joseph.
Thank you.
Let's see. I don't think we have Buff Deep here. Did we have any other extra questions as well?
About some questions about Lambda, maybe, if it's not something earlier.
Sure, absolutely, Nikos.
Yeah, it's just it's better to ask this talking rather than typing, I think.
Of course.
In Sainsbury's, we use a heavily serverless architecture for the project, which involving like some database DynamoDB, step functions, lambdas, etc., and API gateway the way that we working is by uploading massive files into S3 bucket, and that calculates. It's reading the data and then do some calculations during lambdas and then storing to Dynamo. This is the high overview of a serverless architecture. And we are facing sometimes some issues because it's a lot of data. It's millions of lines. Like sometimes we have like API gateway timeout during that process if we have so many requests, or a Lambda itself like sometimes exceeded the time and so on. And as you said earlier, because we predefine all these timeouts, how much long it stays alive and so on, is there any way to actually make the Lambda decide if it has to stay longer open or no? Because the data that comes in, it's millions of rows each time, and there is a calculation. Some Lambda does some calculation before it makes it to a database and so on. That takes more time. And yeah, because earlier, the way that you described is we predefine everything, the amount of time that has to stay on, and the other is like how big data we can accept each time that Lambda is running, and so on. Which sometimes in our case we cannot make sure how long it's gonna stay alive.
Yeah, that makes sense, Nikos. So let me just ask a few clarifying questions, please.
Yeah.
Multiple Lambda functions, so multiple different Lambda codes, or just one?
Multiple different Lambda codes.
Okay, so
each Lambda does like a job. Let's say we have a step function. Each step has its own Lambda that runs, and that does different job concurrently. And maybe then talks to an API gateway to fetch some data from Dynamo, and then do some calculation and send it back to API gateway, which then stores back to a Dynamo. But talking about big data.
So is API gateway the step into DynamoDB?
Yes. So one Lambda uses API gateway to talk to another Lambda, then DynamoDB. Yes.
Okay. So the flow is here. Okay.
And we are making. We have the API gateway. Sometimes timeouts or timeouts exceeded, or sometimes we have some kind of those kind of errors, and maybe sometimes the Lambda. In the past, we have throttles, which now we don't have, but we facing those kind of issues because the way that we specify Lambda has stay alive. Yeah,
that makes sense. Nikos, right? Can you remind me, please, how S3 comes into the picture?
So the idea is people put some massive CSV files on S3 buckets, and then we have like SQS that trigger requests. Then we have Lambdas to read from those files. And then that Lambda reads the lines, which then started some process of manipulating the data. And then we store them into Dynamo through an API gateway.
So through API gateway and Lambda. So the Lambda makes the API call to write to DynamoDB, right?
Yes, and we have authentications to queues, to SQS, like when the next step is going to trigger and so on.
Mm-hmm.
But yeah, we face sometimes API gateway timeouts, and yeah.
So indeed, it times out at about 30 seconds. So that makes sense, especially if the request may be a little bit too large. It's meant for more simpler requests in those cases. A few options here. So let's take the millions of lines issue first. Millions of lines.
Yeah.
Perhaps we can ask how big or how many lines are there within the Lambda code at first to get an idea of whether or not we're going to be running for a long time or not. So I'm going to do this. There we go. So we can get an idea early in the process of how much data we're going to work with. There are some elements. Sorry?
An idea of that is like we put everything into queue messages, and then the Lambda reads from the queue, by the way. And then, but the way that we do it, we ask AWS give us 10,000 Lambdas concurrently, but we have to ask. So how can we make things like we can make it bigger? That I think Micha is asking that question on chat.
There we are. So I see the question now as well. Pros for provision concurrency for Lambda is only two vehicle starts will be more expensive on demand option. So I will show that as well, Micha. Yes. So you only have to request it once, Nikos. So from the service quotas, you could ask here for a huge amount of concurrency. I currently have 5,000, but you could easily request 100,000. So you can have the limit to scale to, but then you can put limits in place before that, so we can allocate concurrency specifically if we want to cap that as well. So this is just to give you the scalability parallel-wise. So that is one way to look at avoiding these exceeding times. But really, if it's still exceeding, even with high amounts of compute and long processing times, I recommend one of these aspects. Checking how big the message is the moment it comes in, because we'll be able to see that as the message comes in. And that can be achieved with context objects. There we are. You can get information about the Lambda, about the various details, so function version, limit in memory, and so on. So you can call that information, and then maybe that throws an exception into your code to stop the process and actually redirect that message as a failed response. So let's put it here. As a failed response to a series of containers, because containers will be able to run for longer, isn't it? Now, the way it will do this is through an SQS first, which will be a dead letter queue. So on Lambda, if we check the possibilities here on destination, notice how based on failure or success, we can do something with that message. And for example, we could put it to a queue from where containers, which can run for longer, can read and ultimately process that message. So does this approach make sense here?
Yeah, we do that approach. It's just more about the timeouts on API gateways. Like we don't know, like, is it Lambda that takes longer? Is it Dynamo that takes longer? Is the API gateway itself that causing that issue? And yeah, this is more kind of if Lambda can, we can make sure if the Lambda will finish the job. How can we be so sure that it will finish the job on that time we're given? And if it's not, how can we move on to the next, let's say, API gateway causing this error? So it's like a chain, right? Like, if I understand it correct, this is a chain of errors that will happen after.
Ultimately, if absolutely, so if it fails, if Lambda fails and it can't send the message through to API gateway that's waiting for this, or actually here, if it's trying to send the message through and it takes too long to put it into DynamoDB, then absolutely it will time out because it's not receiving a response.
Yeah. So serverless, how can we make sure where the problem comes from? Is it the Lambda, or can we put more logging into Lambda? Is it the API gateway that has some serverless issues? Is Dynamo that choking itself or something like that?
So that's what I was about to say. To investigate this as a full flow, I recommend you test X-ray on it to see the full flow of the request. So X-ray will be able to map out how that request flows, and you should be able to see where exactly the request stops, where it times out, and potentially why from logs. So the why, the details you might find in logs, but where it holds, you will find in X-ray, because X-ray will give you this view here. So you'd be able to see, there was an error on API gateway. False. And you can check then the request path. See here how I have different methods invoked, and they're all success response codes. Had they not been successful, quite simply, I would have had an error here. I think I could actually generate one. Let's try. There we are. Perfect. So any minute now, we should see some errors here as well. Well, one, really. One or two, depending if it's a get and a put as well. But we will be able to see that as an example. There we are. See this right here.
Yep.
So let's see. This one took 0 seconds. The GET request failed right away, and the POST request failed also. It didn't go past the API stage. So this is how we can see, oh, there's the blocker, and we can investigate further.
Yeah. Is the API gateway now tells you the reason why, or here is okay, there is an error during the process, but why? My most issue is why is timing out if you can prevent the timeout? Is there any way to actually prevent the timeout before it happens automatically? Because the server is saying we don't have the control of how to do this.
So not to prevent it. If it's going to fail, it's going to fail in that respect. If the message was sent through, basically in that respect. But that's why it's important to have those dead letter queues to be able to process those, to give enough time to process those messages. But of course, here we should either have the message already processed before we get API gateway to interact further. To me, it appears that this shouldn't be an issue for one reason. DynamoDB should work within that 1 second. So if there's an issue, it drops the request because of lack of capacity or improper formatting. But performance-wise, it should be there if you have enough capacity units. If it doesn't, it will fail round about a second, essentially, due to capacity. So if your timeout is at 30 seconds, the best, or if the errors come with a 30-second timeout, the likeliest culprit is API gateway here, but it might be waiting for something else, maybe this process. I would suspect, just like you mentioned, Lambda taking too long.
Can we auto-scale that timeout of the Lambda, let's say, if it takes longest to finish a job, to actually trigger, okay, wait more than the actually we gave to you initially?
I don't believe we could potentially try to make that API call, but it would be an API call within Lambda to say change config on the Lambda function. And even then it might be, it's not a way we advise to do this. Rather, put the timeout that you want. So if you want 10 minutes, configure your function with 10 minutes and simply throw an exception error within your code at 5 minutes if you don't want to go for longer, but at least your top limit is higher if you need to.
So if we do that, then 10 minutes Lambda, API gateway timeouts in 30 seconds, this is in not sync, then that's causing an issue in serverless architecture, right?
That's what, sorry?
So let's say timeout API gateway is 30 seconds after the request. Let's say we design this architecture now, and then we put 10 minutes Lambda calculation. So that means the response will wait 10 minutes, up to 10 minutes. Or if it's more than 30 seconds, means that Lambda will finish its job in 32 seconds, but the API gateway will time out in 30 seconds. Is this a case, or am I thinking wrongly now?
It depends who calls who. If Lambda sends the request to API gateway, then it's not affected by the 30 seconds timeout. It's when API gateway has a method integration with a Lambda function. So on this interaction,
on that one,
yes, in here, Lambda finishing in 35 seconds results in an error in a timeout on API gateway.
So here, okay, this is like something it can be not happen, or if that's the configuration, that will always happen. So we cannot say to API gateway wait for a little bit longer because the Lambda this time will finish in 35 seconds, but API gateway will time out in 30 seconds.
Exactly. So we wouldn't be able to do that. However, let's check one thing. So this is because API gateway invokes Lambda synchronously.
Yep.
Let's check to invoke Lambda asynchronously, because that's what we might need here. We should be able to with API gateway. There we are. So you should be able to invoke it asynchronous, and then you would just receive a response if the message was sent successfully to Lambda, but not if it's processed successfully.
Okay.
Because we're not waiting for the response of the processing, we're just waiting for a response of, hey, did you hear me? Yes. We no longer care if it was processed. So that's the success or failure response you will get. And this may avoid a problem here. This is an option. So either asynchronous or, but this has to be investigated if it's viable for your use case. API Gateway has WebSocket APIs as a stateful connection. But I don't believe this is the right use case here because it's meant for back and forth communication, not just longer waiting times.
Okay, I think I think you covered my timeout question. Why maybe this happens sometimes.
Let me just suggest one more thing here, if you don't mind, Nikos. Maybe EventBridge can help. So your API here seems to be internal in the whole architecture, not as an external endpoint. Perhaps you can use the Lambda payload as an event for EventBridge, and this asynchronously invokes this Lambda function here. So if I go to EventBridge, a very flexible event response solution, I can choose upon a Lambda event, I could configure the event, I could trigger a different Lambda function. But it would be asynchronous by default. So EventBridge is not synchronous, you would asynchronously invoke the next Lambda function. So you wouldn't necessarily deal with a timeout, rather with capacity errors if this Lambda function is all the way up to provision capacity. Does that make sense, Nikos, as an alternative?
Yep. I think for internal communication, we are using EventBridge. I'm not sure, I think, but for external, we're still using the API Gateway.
That makes perfect sense.
Okay, thank you so much.
Does this help, Nikos? I hope.
Yeah, it helps. I thought that there was a way of when a Lambda attached an API gateway, and then there is a request, and the Lambda takes longer to calculate the data. There is a way of actually says the Lambda can say to API gateway, wait for longer rather than with a predefined timeout we set for the API gateway.
I don't believe so. We can check the service quotas, but as far as I know, API Gateway has just that 30-second limit there for the timeout configuration. For some reason, I need to log in again. That's all right. Let's have a look. There we are. We're here also. Perfect. So let's see, it should be a 30-second or sometimes 29 seconds. Thrown rate, duration. Yeah, there we are, 29 seconds. So 29,000 milliseconds, and it's not adjustable, I'm afraid.
Okay. Yep. Thank you. That will cover the questions actually I wanted to ask about.
No problem at all. Miha, are you still here?
Yes.
Okay, so provision concurrency. Generally, it's basically that to avoid cold starts, because exactly like you're mentioning, when we've seen that invoke Lambda function, we have to set up that execution environment, and provision concurrency really just does this. It takes and provisions multiple execution environments so that when you run Lambdas, they go and run straight away. So it's really to avoid those cold starts in that respect. It does cost to set up provision concurrency because you are basically reserving some of that compute capacity under the hood to be ready for your Lambda executions. Otherwise, they would be available for other customers and you would simply just have stored code in that respect.
But if we have like a constant traffic of 50 concurrent lambdas, if we would provision that, would that make a difference in pricing, or if it would be on demand?
So if it's a consistent concurrent solution there, it depends how consistent we mean. When a Lambda finalizes, how quickly does another invocation start? Just continuously a 50 or so function flow?
Yes.
I would say it's something that should be checked in by monitoring. So in your particular case, it sounds like you're avoiding cold starts through that recurrent invocation quite often. Let's go to CloudWatch because we are able to monitor quite a few things here with Lambda.
Yeah, I couldn't find cold start metric here, but I found it like outside.
You're absolutely right. It wouldn't be a cold start. However, right, there is invocation throttles.
Invocation should give like average invocation for that given Lambda if we introduce that metrics in.
Sorry, the average invocation time, you mean?
Yeah, the invocation that invocation metric should give some information, and maybe we can like do an average on this using the.
So the invocation will show when we invoked the Lambda function, absolutely, and duration can help us figure out if we had or not a cold start. Let me check something here. Not here, actually, in log groups. We should be able to see this in log groups, Miha. So ultimately, just to answer your question, it's to be checked if in your case it makes sense to actually provision concurrency or not. If you have a consistent flow of about 50 functions on a continuous basis.
That was just an example. Our traffic is actually quite cyclical.
Okay.
And like we can pretty like assess how much traffic will there be in any time of the day. So yeah, like our problem is that most of the requests are really quick, but then the maximum time is sometimes like 10 times slower. Like I'm talking from 15 milliseconds to then max time is 400 or something like that. And I was just looking for a way to close that gap. So I assume that like those longest requests, why they take so much longer is cold start.
Very possible, Miha, and this is how you would find out. Can you see here in log groups in CloudWatch logs?
Yes.
You could check if there are initializations Basically, you could configure by tailing these log groups and also creating. So I'll go on the log stream here, and I could say create metric filter. So I could treat these series of logs as a metric based on a logic. And in our case, the logic would be to check based on that particular part of the data. You would define your test pattern to see what are you looking for. The initialization duration to be bigger than, say, 10 milliseconds, basically if it exists. So if you have an init duration, there is a call start, and that can point you to how many times you are having a call start. Ultimately, to avoid it altogether, you would use provision concurrency, yes, because the problem with serialized invocation like this, maybe you will, maybe you won't have a cold start, depending on how quick Lambda function invokes after an ended invocation. And that's not really an exact number there. I've seen blog reports ranging from the shutdown period being 45 minutes all the way down to 5 and 10 minutes. So it's not an exact number over there.
Okay, thank you.
Does that help, Miha? I hope?
Yes.
That is fantastic. Okay, Bhavdeep, welcome back as well.
Yeah, sorry.
That's right. So let's see, you had a question as well, if I'm not mistaken, yes?
Yes, and I think I lost it because I dropped the meeting.
That's okay. I have it here. So I think it was this one.
Yeah.
Okay, so let's have a look.
So it is like the next day morning we need to share this report of the failure which has happened for those particular order and along with the products.
Let's break it down here to see a little bit what happened. So a number of products, product order. This is the payload. Okay. Processing from third party, right? So we have this third party integration, which we don't really know what it is or what it does.
Yep. It's just like it will try to see the values and everything, and it will say, yes, I am able to like say this is a validated request, and yes, you can go ahead with your journey.
So validation at the third party side or not. And we can't see why it validates or it doesn't validate, isn't it?
Yeah, the reason won't be given of like why that fail have happened from their end. So it will be just like either your value was not correct or maybe that product no longer available in their site now.
Mm-hmm. And this is what we'd like to know.
Yeah, so if any of this product fails now, and since it's a part of a single order, till the time that complete order is not been initiated, like the complete order is not completed, it's not like an order is been given. But what in our case is happening, even if we say like one product has been given, that means it has given everything. But in general terms, it hasn't given you everything. It has just the call has been made success for only one product, not for all products. So we need to validate that all products has been validated in the third party side.
I see. So it's a whole order where some products are failing and others are
passing. Yeah. But for user, it will be like a success. So now we need to like make sure that for whatever it has failed, those products are being taken off.
This might help. It will help, of course. So let's see here. This is what we're receiving, and this is what the user, the end user, is also believes.
For end user, it will be like all the 5 products. So
yes,
for him, it will like he will be having an assumption that it will be all the 5 products, but it is not.
So this is the user. Does it enter your solution before it goes to the user?
Yeah, it will come to our solution.
Okay, so Sainsbury here.
But the problem is like we are not sure, like if your first call succeeded, that means for user it will say it is succeeded, right? But it can happen like after 5 minutes it came and did a call for the second product and that is failed. But user has already been given an information that it has passed for him. So now it's an internally which we are trying to manage, saying that okay, for this product, if there is a failure, I'll be informing, I'll creating a report and we will let user know from different channel about it.
Mhm. Do we know how this message comes in? Is it a JSON document? Is it a series? Is it a JSON list of series of entries?
No. So it will be a JSON document with only one entry in it. Like for that, like it will be having a order entry, not a product entry to it. It's an order entry. But we know what product has been passed as part of this second call. So we can pass the product along, like we can get that product, what product was it is which failed.
So we know we know the products based on the order entry because that lists the products, isn't it?
Yes.
Okay.
So the current solution which I have gone through is like, so whatever that the product which is failing, I'm adding those into the S3 bucket for now.
Mm-hmm.
The caveat was like initially I was trying to do with the Dynamo database only, but the problem with that is like our partition key is different. It is not the product ID over there or the order ID. It is completely different. It is like customer related data something. So now I cannot relate it with customer because in this call, I don't have anything for customer. It's just a product and order. So it has got no information about customer now. So that DynamoDB approach was not going to work on that because we need to come up with a secondary index, and that can go through the complete cycle of understanding about the performance impact and all. So the solution which we put it as of now was like we put all this data into a like a S3 bucket whenever those are failing because we don't know by when it will fail. And later on, we have created an event bridge and a Lambda function. So that event bridge will run every whatever the time we want it to run. It will trigger a Lambda, and Lambda will read the data from the S3 bucket, and it will create a report and it will share it across with the team. So that is how we have created it as of now, the solution. But I'm trying to like avoid, because since we know this data is not like a data which is been like which needed for longer, we are just going to read the data and then pass those information and then again deleting it from the S3 bucket. So we are not keeping that data in S3 bucket for longer also. It's just like if today it happened, by night it will process it and it will share the information and that data will be deleted. But for the time being, we are like we have created it into a backup folder just for the time being. But it's just an like a solution, a POC kind of thing we have just created for now.
Yeah.
There are like any such events happening also in general scenarios.
Yeah, that makes sense. And I see over here. It's a bit of a more complex solution, especially like you said, if we don't know, because we don't know how the third party validates these. Is this an order fulfillment? I take it third party, if I understand correctly.
Yes. So what they are doing, they just want the order number, like what is the order and value associated to that order. And they internally will like say, yes, I have approved it. That's what they are doing on their side.
Okay, but and we get it in a way that we know what wasn't approved and what was approved.
Yeah, we cannot. So just for example, if those are the two things only, if I have to figure it out now, if you have passed two product with same value, I'm not sure whether it is product one or product two which fails. So that was another. And on top of that, if I include quantity in between and just assume like quantity is equals to some value to that, like the amount which is for product 1. Like product 1 is of $100 and maybe product 2 is of 50 quid, but there are like 2 quantities to it. Again, it will become 100. So there are so many like probabilities were coming. So we decided like, okay, the approach we can do is like, if there is failure, whenever the second call go through, we know what product it was. We know the order, and we know the means we know like this is the application which has been ordered. So in order to keep that information for longer, because the report will be generated in the late night or maybe after 3 days or after a week. We need to keep that information with us till that point of time.
Of course.
If we would have an application related information available, we could have kept it into the DynamoDB with multiple entries of it. But the problem is like the partition key is not the same over here. So we cannot keep it in the DynamoDB. Otherwise, we have to do a complete traversing of the data and figure it out the customer based upon the name and other details, and then put those information over there.
So it could help to have that global secondary index, like you're mentioning, Bhavdeep. It wouldn't traverse necessarily just the entire data. You can choose what attributes you're projecting to the index. That is possible as well. But I'm sure you may have come across this possibility in
So with this approach, the only problem was like we are going to touch the existing database indexing which has already been done, the partition key which has already been created. So we have to go through a complete cycle of like performance impact of it and other like soak testing and other thing where all the impact can happen. So that's the reason we didn't touch the existing solution. So we just came up with a kind of a on top of it what can be done for now. So I was just thinking like, is there any other way like or any other place like I should keep this information and just process it? Because as of now in S3 bucket also, as I said, we are deleting it. We are not keeping it longer. So that is something I'm doing, but just wanted to make sure is that a good approach, because this is where we are in a mess right now.
So it appears like it's a good intermediate solution here. That's what I was going to say. It does appear like you should be still going towards the DynamoDB approach for a secondary index, because ultimately that's where your data is stored. Or so the performance impact, like you're mentioning, it shouldn't be a particular offset there in creating that GSI too much in the sense that the GSI will have its own capacity units. Once done as well, it will copy those details from the main database, of course, from the main table, but it will have its own capacity units. However,
there is already a GSI, existing GSI is there. So I have to add another on top of it. That was the reason we were like, if we do it again, we need to make sure the indexing is correct. Like we are actually
to it. Let's check. I think, if it's the nice thing about the cloud is we can experiment. You can trial, and then if it doesn't work, you can revert back certain changes. The GSI should be one of them. LSI is the one that we can't really do anything about once we have the table. So let's go to indexes here, not to this table. So give me just a second here, please.
Oh, that's fine. And like if we are going to do that, the problem is like the production database will have the main volume in it, right? And in our staging environment, we will be having only 20-30 data. We don't keep that much data. It's just like a play up for us. So with that, I won't be able to give a justifiable answer saying that whether there was an impact or performance impact on it. So now like how I can do it also, like if I create the index also, like I'm not sure like how I can run through those reports and gather a idea saying that, okay, this won't be a drastic difference on the like whenever we make any Dynamo queries.
Yeah. So we can, if we do make an index and it doesn't work, we can get rid of it. So that's a revertible choice there. If we don't want to, or we want to keep things separate, on the DynamoDB table, on the main one here, what you could also look at potentially is enable DynamoDB streams. So DynamoDB streams will take data, items that have been created or updated on the database and keep a record of the changes, the old item or the new item.
Like the versioning.
But the versioning as well, in that respect, I would have to check actually on the versioning, but ultimately it does keep the data of the item versus the old item as well in that stream. And from that stream, you could potentially read it through a Lambda function by calling in that way, and write it in a completely separate table from where you could create your report as an example, or maybe Lambda directly sends you bits of data to report on, essentially.
So, but again, the problem is like the word, like if it is going to look at the old image and the new image. Now, as part of this example only, you can see like we have got 5, and it has failed for like first, third, and fourth maybe.
Yes.
For fifth, it has passed. So will it have all the images like 1, 3, and 4 also will be there part of that, because there will be 5 calls. So I'm going to have like 5 different images every time it will be updating.
Well, it depends how you configure the DynamoDB streams, which attributes you would like to send to your stream, whether the ones that have been defined as keys or the entire item. So here it depends on how it's configured at a granular detail. Also, whether since this, as you mentioned, is just one JSON payload, you should, if I understand correctly, you should take all of your data here. So as one logical message rather than individual ones.
No, the messages are okay. It's call, but the calls are happening individually, right? The messages is fine. The calls are happening individually, and then we need to update it accordingly. So it will be like you make a call for first product, you update it. But the bulk, we are sending it. But internally for them, they cannot handle the bulk request. So we have to give them separately one product at a time.
I see.
One product for one order, this product, the problem is like they don't say product, they just say number, the value to it. The order and the value, the order and the value. And we can get back order ID from them. So that's another problem. We cannot store the order ID saying that, okay, there was something going wrong with this order. So we just get success or fail. That's it.
Per individual product. Yes, and that's an individual payload, but you just bulk them together for the report purposes.
Yeah.
Okay. In that case, we would see the individual items in the stream, and potentially we have a conditional statement on Lambda to check for a particular attribute on that stream for just the failed response. So as the failed is an attribute, potentially a Boolean figure, I would suspect, unless you're persisting the error code from it, then we could selectively choose just those messages and discard the successful ones since they've been successful. Yeah. So we can then generate just a report on the failed ones.
Okay, the same thing which I did it in the S3. So in S3 also I'm doing like if these products are success, like, because since there are 5 calls, so we are not sure like all the calls are going to be success. So whenever a call has been made, I kept it in my S3 bucket. Okay, this is in process right now. But like if all the calls are been done in my Lambda, the way the code I've written is like it will check if it is success, then just ignore that file and go away. Like just do it for the ones which are going to the failed blocks. We have already segregated that as part of our S3 calls. Like whenever we are doing that. Okay, I'll explore then that stream once I've come across first time. I'll see what it is.
Absolutely. Give that a go. That might help. And from there, like you said, disregard the success ones, write the failure ones in the report, or get them through a retry solution. Perhaps you can get this Lambda function to reattempt calling the third-party API, I suppose, or however it is that you're handling those failed validated messages.
So it's like the first bit of the diagram, like where you have created that blue arrow, from there actually the call is initiated to the third party, and
directly here.
Yeah. So this is a connector to the third party. It generates any error that we push it into the S3 bucket, and then a Lambda kick in at next day or 7 days, depending upon the schedule. And then it processes those, whatever the products which are into those respective folders, we generate a report out of it. So that's how we have done it as of now.
So hopefully, sorry?
Roundabout thing we did to get it like without impacting existing solution, get everything in the working area.
Of course. So does this help Bhavdeep at least to give you a direction?
I'll explore that DynamoDB stream thing and see how we can like do it from DBs only rather than going for S3 bucket.
Absolutely.
Knowing the cost involved in it.
So hope this helps, or at least point you in a different direction. Maybe have a look at Kinesis data streams as well. We will talk about this tomorrow in very high level, but this also enables you to do some sorting and ordering per shard as a messaging service. It's not like DynamoDB streams, it's different, but it does offer some more capabilities of sorting and sharding. So I think more recently, there we are, we can actually turn on Kinesis data streams as well.
Okay. Okay, sure. Sure, I'll explore this part. Yeah.
Okay.
Thank you so much, Stephen. Thank you.
No problem at all. And my apologies, but I hope it makes sense why I took this question separate instead of addressing it live.
Because that's fine. Yeah, that's fine. I'm not sure. Like I have actually took a lot of people time if they are listening. I'm so sorry, guys.
No, that's right. That's why we have this time. If they listen in, it's a learning benefit, but at the same time, volume can be taken down and lab work as well. So that's perfectly fine. All right, Bhavdeep, I'll grab some lunch as well. But any other questions, I'm here if anybody needs me.
Yep. Thank you, Bayal.
Thank you as well.
Hi, everybody. This is Carl Grove speaking. I'm just jumping on this call quickly as I was asked by Stefan, since there is an actual fire drill where he is right now. So if you can all hear me, or if anybody could maybe just give me an indication that you can hear me, maybe in the chat. Just checking that everybody's okay. He should be back soon. Let me just see there. I got some thumbs up. That's good. Awesome. Okay, right. So I will just communicate that back to him. Thank you so much for letting me know.
Hi everyone, welcome back. Hopefully we are all back, luckily myself as well, in a all good capacity. So please disregard this aspect right here. Luckily, everything is now okay. It was an actual real emergency, unfortunately not test or a drill, but luckily we are all okay. A little bit tired for running around trying to sort things, but we should be all good. So everyone, are we all back? Give me a quick thumbs up or a +1 in chat if we're all here, ready to carry on further. Fantastic. Thank you very much, everyone. Just trying to just carry on without the glasses for now, and I'll look for them afterwards. Right. So before lunch break and an eventful lunch break, if you will, hopefully just in my case, we were talking about S3. We technically covered most of it, and then databases as well. However, we've left a few elements to cover after lunch, such as caching and migration capabilities, because of course we have quite a few different database engines that we can use, and not just the ones that we integrate on RDS, but others as well. And yes, absolutely. Thank you very much, Carol. Much appreciated. Thank you. I have had a colleague on standby just in case there was an actual issue to take longer, so someone would have been here ready to pick up in case I had to be gone for longer. Luckily, that's not the case. So everyone, we talked about different ways to look at performance in our databases, but it is with the databases specifically. Now, if we need to really improve latency, to decrease latency, to improve speed of requests to relatively static data, this is where caching comes into play. Caching is best for data that doesn't change often. If it's continuously dynamically changing, then we shouldn't really cache it. And ideally for frequently accessed data as well, popular one. Or data that requires slow and expensive querying as well. Usually, we put this in between our data layer and the application layer as well. And in terms of generic strategies of caching, we can be looking at solutions such as lazy loading. We're not talking about a specific caching engine here, more as a generic concept, where we are, let's actually draw this out so we can look at it slightly differently. Let's have a data layer here, such as a database and a cache, and some clients making requests on this side. We have, let's say, green records. I'm going to say record 1, record 2 here, record 3, and let's go with, let's leave just that much actually. Right, we don't have any requests to the database yet. This right here is the database, and this right here is the cache. So let's get a customer, a client, to make a request to the cache for the green record, for record 1. Will they find this in the cache? Based on what we see on the screen, of course. No, absolutely not. It may be an obvious question, but I'm just trying to drive home a point. This is what we call a cache miss. So we will have to direct that query to the database, and we will look through the database, query it, and we will find this record, which we will bring back, populate the cache, and then return the response to the customer. The second customer also requests record 1. They go to the cache, and the question is, will they find that record? Well, in this particular case, yes, they will. This is a cache hit. We found the record here, so we don't have to make another trip to the database. Therefore, we both alleviate some of the burden, the performance burden on the database itself, as well as being in a shorter distance Well, probably distance is not the main aspect here, but rather less data to look through in the cache. Generally, cache solutions are smaller amounts of data than their database counterparts. Generally, that tends to be the case. Of course, you could have the same cache size as the database, but then it functions almost more in the lines of a replica rather than a cache itself. Let's keep moving here, and let's say we have a customer requesting record 3. They will go to the cache, of course. Will they find the record? No, that is a cache miss. They go to the database, we bring it back, we bring it to the customer, and we also populate the cache on our way back. This process of continuously looking into the database as requests come about is us not choosing a caching strategy. We are leaving up to the customers. This is lazy loading as a concept. Now, we will address the other possibility shortly, but let me ask you this, everyone. Customer, this one, looks for record 2. Goes to the database. This is a cache miss, so we will go to the, goes to the cache. That is a cache miss. We go to the database. We come back with the record to the cache. And which one do we replace? Will we replace record 1 or record 2? None, oldest, least used? It depends. It is configurable. That is indeed correct. It depends. We might not even replace anything. Could be none, could be least used, could be oldest as well. All of those answers are correct. Really, it depends. It is a configurable option on most caching solutions. We will return it back to the customer, but the idea is that we choose as well. And the other option that we have here is this. Let's say we populate the database with some records, and then we also do this. How many requests did we have to our website, to our cache, to our database here from end users? None yet. We decided to populate the cache ourselves. This is what we call write-through. We decide to populate the caching solution with the records that we deem to be the most popular or the best suited to be cached. It is our choice. We decide as we write to the database to also populate the cache. This will effectively impact that first request latency, because even the first requester, be it the green or the blue record, both of them will be a cache hit, and we will return a success response with the data straight from the cache. We choose the amount of data, we choose the data specifically that we want to cache as well, so we make those choices. But again, let's go back to the database for record 2. So we go and look into the cache. This is a cache miss. And now let me ask everyone, who goes to the database? Is it the cache or is it the user? Or client. Ultimately, I'm drawing them as stickman figures, but it could be a device on a network. Could be the app tier as well, of course. Most people are saying cache. Well, everyone really is saying cache, and that is the better choice, of course. We would refer to this as inline cache, where we're basically putting the cache between the data tier and the requester, And this is what we would call a side cache. Both of them are technically possible, but this one is the more secure. So caching is generally used, of course, for performance improvement, but as a tangent consequence, it can also increase the security of your database. We have the same type of explanation as well through the slides as well, just slightly different graphics. And remember, managing your cache, that's up to us. We also decide when we want to expire the records by setting a time to live value, a TTL, if you will. But then how do you manage the memory? Well, like we said, you choose the least recently, least frequently as well. Essentially everything that you've mentioned there in your answers. Basically the it depends answer. And in terms of services, we have Amazon Elasticache, which pretty much like RDS is a solution comprised of two different services. It's Memcached and Redis, with quite simply the differences being Redis is cleverer. It's basically able to perform more advanced elements as well as sorting and ranking advanced data types. Even if you go for the AWS Solutions Architect exam, you don't actually have to go into these details. Just remember, it offers more capabilities, including backup and restore. So if we check these two solutions here as caching solutions, both Redis and Memcached are technically clusters of nodes like this. It's just that when we put data into a Redis cluster versus data in a Memcached cluster, Memcached or Memcached cluster, from Memcached we use in a parallelized way all the nodes to retrieve the data, whereas with Redis we could technically just use one of the nodes because we are replicating the data across multiple nodes, and we can also back it up. So in case one of the nodes fails, we can restore from a backup. Please do remember, this is a backup of the cache, so even if everything goes away, you should still have your database with the original data as well. So we're really talking about an extra layer of protection on the cache itself, not the database original data. And other than that, a few additional possibilities here, and that parallelization with Memcached is because of that multi-threaded performance. Before we move further, we have a question from Nikos. User 1 is reading record 1 from cached, while user 2 editing record 1. How the cache will... I see. My apologies, Nikos. I wasn't sure what you meant. Are you referring to this example or this one here?
The first one.
Okay.
The previous one. Yeah. Yeah, like when the user 1 reading from cached the record 1, but then another user or someone from a database administrator editing the record and the record run of the database has different data than the cache. How the cache will get the updated record from the database?
Again, it's a matter of it depends on the service and on the configuration on the service. So, like you mentioned, let's say it is Thursday. We update the record. We issue a put request to record 1 to modify it here to say record 1.2. One of the options is nothing happens until Friday. So in other words, 24 hours. On Friday, we take this record and we populate it in the cache. It's based on the time to live. If we set a time to live to expire the records on the cache, upon the expiry, the cache checks the original data or it expires it to make room for new data in that respect. Additionally, we could force And I'm going to put this in quotation marks because it's not really a technical term. It's just to illustrate that I could publish this record to the database and force an update to the cache. Therefore, it's my choice not to wait for the time to live to update the cache. But it is a configurable choice, Nikos. Does that make sense? Yep, that is perfect. And Andrew, can you use ElastiCache with any database? How would you do role-based access control? So ElastiCache can be used with multiple databases, including RDS and DynamoDB as well. I would have to check all the integrations, but I'm sure we can find that as well. It was ElastiCache integrations. So let's have a look. So it definitely works with RDS and DynamoDB. I suspect it works with others as well, especially document databases. So let's see. Yes. The rest is database instances and DynamoDB. Self-managed databases on EC2s. Okay, so there we are. It seems like, so RDS and DynamoDB, like we mentioned, and EC2-based ones. Others don't seem to be supported with ElastiCache quite yet. In terms of access, Andrew, these ElastiCache nodes are, again, nodes. It's instance-based. So they will lend themselves to the same instance controls as an EC2 networking side as well, for example. So let's go to ElastiCache. We would have to put it on a network inside a subnet or across subnets and in security groups as well. So if I create some nodes here, let's go with a Redis cluster. That's fine, that's fine. Network, there we are. So let's choose an IPv4 network, subnet. I'll have to create a new subnet group. That's fine. In this VPC, that's okay. All of these subnets as well. And there we are. That's how it would. That's how we create a configuration here for these subnets. Sorry, for this ElastiCache cluster, and these are the nodes. Probably should get rid of this as well now because they're quite big nodes. But essentially, it's an instance type that's designed to work as a cache. But it will essentially create those nodes, ElastiCache managed nodes, just like instances, but they're cache specific. Does that make sense, Andrew? Or actually, my apologies, you mentioned role-based access control. It doesn't appear like we can configure IAM-based permissions or role-based permissions, and the answer for that would be they're not meant to make API calls apart from connecting to a database. So we're talking about the interaction with a database rather than API calls specifically.
Yeah, okay. So I was thinking more like in the databases, you'd have roles and groups within the databases. But if you gave somebody access to the cache, then how do you control access to the queries that were in the cache to somebody? So you'd basically see all the queries on the cache, would they?
I see what you mean. I see what you mean. My apologies. I was thinking something else over there. I would have to check that, Andrew. So if you don't mind.
Yeah, sure.
Yep. So I'll have a look into that to give you more details in that respect. So let me take a note of that question. There we are. So I will have a look into that and get back to you with some information.
Okay, thank you.
No problem at all. There we are. Let's get rid of this. Okay, still not ready. That's right. I'll come back to this shortly to delete it. But that is Elastic Cache, everyone, from an architectural perspective, of course. Like we mentioned, we don't dive too deep from a functionality data management side, purely because of the focus of the course, mainly. However, whilst this can work with RDS and DynamoDB alike, DynamoDB does have its own dedicated solution called DynamoDB Accelerator, or DAX for short. Whilst DynamoDB is serverless, DAX is actually node-based, but it does use the same configurations as DynamoDB. My apologies, it's a direct integration with DynamoDB. It's almost as a drop-in tool. You are able to essentially take milliseconds level of request and bring them down to microseconds, really driving that performance to the absolute most performance that you can get out of DynamoDB. My apologies. But whereas DynamoDB doesn't need a virtual private cloud, a DAX cluster would do. Right. Just because we came back in a way to DynamoDB, let me finalize that conversation by mentioning, yes, DynamoDB is in a region, but that doesn't stop us from actually taking it global. Like we've seen with RDS, and we can take read replicas across region 1, 2, 3, and so on. DynamoDB can do a similar process. However, global tables enables multi-read, multi-write replicas. There is technically no primary in this configuration. There we are. It is a solution where you are replicating tables across the world in a multi-read, multi-write fashion. And if we have a look at it here, in DynamoDB, it's quite easy to set up as well. It's quite literally just creating a replica for your table and pointing it to a specific region. And if I select a region and create replica, it will just replicate my, ultimately, JSON documents across. And this is arguably a little bit more information. It is in the slides, but it's generally not quite needed to this level of depth for architect associate. It tends to be more on the developer side, but it's about those requests to DynamoDB specifically. Remember how we mentioned DynamoDB works on the concept of partitions identifiable by those partition keys? Where did we have it? There we are. Well, imagine there is a put request for author 1 to update this record and add another attribute. I'm going to say extra data. So that put request will require DynamoDB to start updating individual partitions here. It will happen very quickly. We are talking about milliseconds here. But at the same time, there is a GET request for author 1. So the green one is a put request. Blue is a GET request. DynamoDB uses a partition to retrieve the data. So which one should we retrieve? Let's say version 1 or version 2. What do we think? it is actually an it depends still. We can influence this. If we want a milliseconds faster request here, but we're not worried about whether it's version 1 or 2, we can choose eventual consistency. This could retrieve stale data. It might actually retrieve this record. If we choose strong consistency, that will wait for all partitions to be updated here, and then it will return the latest data because it doesn't matter which partition it reads back from. This is effectively strong versus eventual consistency, and it's a configuration element passed on the read request. By default, we use eventual consistency, but if you pass a parameter to use strong consistency, that can be possible as well. And the idea is it costs double. Ultimately, we pay for the read capacity units, so strong consistency uses twice as much capacity than eventual consistency. This doesn't really tend to be much of an aspect in the Solutions Architect exam if we, for the ones interested in the exam, but it's still good to know, especially from an operational perspective, because that defines both from a cost perspective, your level of expenditure with DynamoDB, as well as accuracy levels. And as we can see, everyone, all of this really just breeds a lot of choice. Therefore, sometimes we might need to make some changes in our choices, or in other words, migrate. So we can use something called the Database Migration Service from AWS to migrate from on-premises to AWS, or vice versa. Or actually from AWS to AWS as well. Irrespective of the way, one side has to be AWS. Not everything is supported though, so we can go from MySQL on-premise to MySQL on AWS, from Postgres to Aurora Postgres as well. And in some cases, we could go from one engine to another, but we do have to check and we have to make a conversion. And that's where the schema conversion tool comes into play. And Andrew, that's why I mentioned, I think this is where we could have a look at here. Teradata is something that's supported to be migrated if that's something you're interested in, because what I'm thinking here is, if we look at the schema conversion tool supported conversions, we should be able to find Teradata. And there we go, we can go to Redshift, which more recently has become serverless as well as an option. So Redshift as the data warehouse, it can scale quite a lot as well. I believe in its maximum configuration, it's something along the lines of 16 petabytes. So Redshift. As well, just to kind of show that aspect. And in the meantime, I'm trying to get rid of that cluster there. There we are. Redshift serverless is also possible, and it can also scale. We go into the nodes, create a cluster. Let's see, in the maximum configuration, 120 terabytes per node. There we are, 16.4 petabytes. Now, of course, this is just to show the maximum that it can go to as well. But you don't have to go to that size. I believe you mentioned about 90 terabytes. So, of course, that would be much smaller as well. And you can scale from there. So something to explore if you're interested in Andrew as well. The idea is, sorry?
Yeah, thank you. So, but I think with Redshift, as we've looked at it, it's Redshift's column-based rather than row-based.
That is true. It is
So
columnar storage.
Yes, we've never tackled that. What that would actually mean. So,
of course, that's of course one aspect of migration. If you're interested in learning more, I do have colleagues, for example, that address migration capabilities, and this could be a scenario there or a question for them as well. But if you want me to look into it as well, I can do some exploration on that side to give you more to go on.
Yeah, I think it's a big topic, this one. So
absolutely,
yeah, park it. Yeah,
of course. But ultimately, everyone, there are some possibilities here. Not every move is possible. Best to check documentation here. Even this is a slide, so ultimately, it's not going to be documentation is going to be the ultimate source of truth. So everyone, as part of this module, we've helped our database service manager answer questions such as what solutions do we have and what do we have for NoSQL or for relational databases. Likewise, how can we maximize performance and also migrate by looking at RDS, DynamoDB, caching, and migration tools. So, before we move further and build on top of this current knowledge where we've addressed databases, file systems, servers, and the networking side of things, but we still have to address high availability. So before we do all of that, do we have any questions? And if no questions, as always, I'm seeing a few thumbs ups, just waiting to see if anybody else is thinking of a question or anything of the sorts, of course. If there is any question that I may have missed, I do apologize. Please do remind me if there's anything I promised to get back on and it might have, or I either probably just didn't see in chat. I'll be more than happy to have a look at it. We did address quite a few during lunch break as well. So hopefully, apart from Andrew's question that I mentioned, I'll do some further research on. Shouldn't be anything further. All right, it seems like we are okay here. In that case, everyone, let's have a look at implementing high availability with module number 7 here. Okay, come on, module number 7. There we go. So everyone, what drives your decisions to scale? All of the above. It does tend to be quite a common answer. A or E does tend to be a very common one. Ultimately, they do interrelate to some extent, don't they? Usage patterns are needed in order to have expected growth, and even that expected growth is within the limits of budget as well. And really, we are scaling because we want that workload, even if it's not critical, and we set it to 1, that drives a very low scaling decision because it's a low criticality, but it's still somewhat driven by criticality. So we could force all the answers really if we wanted to, but of course there are more important drivers than others. In this module, we will explore at quite some length how to achieve scalability and high availability by gathering information and reacting to it, by distributing requests evenly or cleverly, and scaling based on this information. So really, we will tackle 3 different services by looking at CloudWatch and others, elastic load balancing, and auto scaling. So we will be helping our operations manager here to answer a few questions, such as the tools, which we've just seen, to use, and what thresholds we will use those tools to react to. And how do we add high availability into our solution? Well, in order really to do anything, we need to understand what's going on. And the way to understand is to monitor. Monitoring is all about getting information in. Information for different purposes, for looking at operational health or at application performance. Perhaps we are interested more in the functionality rather than whether it's healthy or not. We want to know if we're using our resources well, to make sure we don't just overly provision resources or under provision them. And we might want to know if there was a login, there were failed login attempts, 5,000 of them in 30 seconds, because nobody types that fast. This is definitely a sort of attack trying to compromise some credentials or to brute force them ultimately. Or other elements of security auditing, maybe malicious IP requests, maybe particular calls to specific restricted ports, and various unauthorized requests. Overall, it is important to have a strategy and a good service to gather data in. And CloudWatch is a near real-time metric and log collection service. Unofficially, it's becoming the one-stop shop for monitoring needs, and we will have a look as to why we, or why I sometimes refer to it that way. It gathers data. Its primary function is to gather metrics. And metrics are time-ordered data points that go throughout your solution. They could be CPU utilization, network in, out, invocations, number of errors, duration of requests, and more. It is countable data points. And we can have quite a few of those. So let's go to our solution here. Let's have a look into CloudWatch. Because before we even do anything, we should know what's happening. Or at least we should have a strategy for that. There we go. Finally, we have this. Let me get rid of it. That's fine. Good. So, metrics, everyone, from CloudWatch. There are quite a lot of metrics split across namespaces, and AWS creates namespaces for AWS services. As you can see here, config, EC2, events, firehose, Lambda S3, and more. Even custom namespaces. Interestingly enough, I'm pretty sure I've seen a different custom one earlier, which I don't see anymore. Yeah, there we are. It's not there anymore. But the idea is we can send custom metrics as well. I will repopulate the custom one during the break to show you. Actually, that will just affect the graph. That's right. Yeah, so that metric is gone. It's been a while back, but different metrics depending on the service. SQS, for example, queue metrics, number of messages, age of messages, something else. DynamoDB, which we just looked at. Let's go over all the account. Number of reads, of writes as well. Provisioned capacity also. Maybe we want to check the provision capacity utilization so we know whether we're within over or under provisioned. And much more. It's countable data points. The thing is, this is data that is important to us for various purposes. First, we can analyze and look for it for later analysis. Or we can act on it. So, whilst we do have a little bit more of CloudWatch to go through here, I will make a small digression because the topic is meant to be along the high availability idea. So that's predominantly what we're interested in. Let's just save this to make sure we don't lose it. There we go. And let's have a look. Let's get our VPC in order. Let's get our subnets. Let's get our private subnets as well. I'm going to create some EC2s here because we need to have an application front and back end tier. And let's create a database as well. We've already addressed how to implement high availability in the database side of things here. So we would have a multi-AZ standby, and of course it does depend on the engine as well, but generally it tends to, it is possible for most of the options. However, we have customers accessing and utilizing our website. And that's fantastic. We've implemented high availability in terms of spreading our EC2s, but where will these requests go? We don't currently have a way of choosing one of the endpoints here as a destination. So we need a central element here that, even though it kind of looks like it's in an availability zone, it is not. It is a load balancer, an elastic load balancer. And what this does, through the use of something called target group, it defines which resources we send our requests to. So it's able to act as a central endpoint at a regional level. So it doesn't go across regions here. It's within the region, and it is at VPC level, even though it kind of looks like it's in one availability zone or subnet. And it can map to its targets in target groups. I'm not sure why I call it a grouped. There we go. We are a little bit more highly available here. The Elastic Load Balancer is a managed resource. It scales by itself. AWS manages that. But my question here is this. What should we do now? If needed, I can add more. So that is the technology, Duncan, and you're absolutely right. But let's arrive there. So what should we do as this happens? I'm afraid, Arslan, that won't affect things here too much. It depends what we're looking for, but it won't help with what I'm doing here. So we will scale. You're absolutely right. The thing is, we won't know what to scale on unless we have those metrics. So this is where CloudWatch comes into play first. CloudWatch will be monitoring our environment. It will look at metrics, and one usually relevant metric is CPU utilization. And we can monitor it from 0 to 100% based on how many users are coming in. Now, with metrics, we can define this. Let's monitor the whole target group and get the average of CPU utilization. So let's get a graph here. Let's get not the best graph, but we will work with it. Let's say our workload is something like this. There we go. And we define a threshold. I'm going to put the threshold here. Let's say my choice is between 0 and 100% to define that threshold. This is the CPU utilization, and this is time. When would we like to know, at what value of the CPU utilization would we like to be alerted? From an operational side, what do you think is a comfortable value? About 80, 85%. I agree it's round about that figure, so let's go with 80. Nothing happens, nothing happens, nothing happens, nothing happens. Nothing happens at this moment because we have to wait to see that this wasn't just a temporary breach. Rather, we wait 1 period, 2 periods, 3 periods, and here we raise an alarm. Why 3 periods? It's our choice. Could be 3, could be 1, could be more, and their length is also our choice. And we raise an alarm. Kind of like what I had literally just about an hour ago as well. Based on that previous example. Does the alarm push me out of the building? The fact that something rings and says ding, 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 does that make me leave? Does that physically push it? No, absolutely. But it does trigger me to do that. So an alarm by itself doesn't actually do anything. But this is an event that we can use with an inbuilt functionality to another service called auto-scaling. Because really, the purpose of monitoring the CPU utilization is to know when to add or remove more instances. And that is defined in an auto-scaling group. An auto-scaling group will define a minimum and a maximum value. In our case, the minimum seems to be 3, and the maximum is something else. Let's ask, What is the technological maximum here? So there is a technological limit of how many EC2s I will be able to launch. Number of IP addresses. Very good, Dave. Absolutely. That's absolutely right. But that's just about 65,000. Like we mentioned, there's a couple of other limits before that. But we're still talking tens of thousands. What is a more likely, more down-to-earth aspect that drives the maximum here? That pretty much every solution has it as a restriction in one form or another. Any company has this maximum element here. Something that drives how much you can use of something. It's not even just AWS. Cost, billing, budget, absolutely. Cost is usually the main driver behind the most units of compute that you will launch. Of course, in a development situation, you would have a smaller aspect, but it's ultimately still down to cost. You don't want to launch too many resources of something. Rarely, it's a different driver. It can be, of course. Maybe this is a data producing solution and we don't want to overload an endpoint to which we're sending messages. So we could drive that as performance related. We might have a bigger budget than that, but we don't want to flood a downstream endpoint. But in our case, as a website, say Sainsbury's shopping website online, we might want to be able to scale to address as many customers as we want, as they want. But ultimately, we have to do it up to the budget limit, isn't it? And very importantly, as we did have various recommendations of scaling, auto scaling is horizontal. Now, we will see shortly when we configure this that technically I can add multiple instances of the same size. I can add multiple instances of varied sizes. This is not vertical scaling here. This is a new instance. The next one is also a new instance. The next one is also a new instance. So they are added or removed. Autoscaling does not stop, change, and start an instance. It just removes it or adds a new one. So we are strictly talking about horizontal scaling here. And ultimately, everyone, coming back to that metrics idea, based on an alarm that is triggered at, let's say, the 80% value of this metric, that will function as an event to make the desired capacity, a floating data point here, desired capacity, change from 3 to, well, so 3 to 5, all the way to 9, depending on how much and how big the breach is and how we've triggered, so how we've configured auto scaling. Something that we will dive in deeper shortly as well. But I wanted to address the holistic example, the holistic topic here of high availability before we dive into the specifics. So overall, everyone, this is how we can ensure that through elastic load balancing, CloudWatch, and auto scaling, we have a highly available solution. So, does it make sense so far, or do we have any questions? Or does it make sense and we have some questions? Whichever way is perfectly fine.
Sorry, question from my side, Stephen. Elastic load balance. I know there's lots of load balancers. There's application load balancers. There's network load balancers, and then the rest of the load balancers. So elastic load balancer is a more purpose this kind of scenario. I just want to understand. I know you use database and applications, but I'm just trying to differentiate between them just to get it across my head.
Of course, that is a very valid question, Arslan. The way I usually get into this one is by looking at it high level first to understand the concept, as all load balancers act as an entry point and then distribute the flow. You're absolutely right. It depends on the purpose, which one we choose. Are you happy for us to explore that after the break as we do so anyway? Or would you like to address that now?
After the break, that's fine.
Okay, that is perfect. So I'm not trying to defer the question, if you will, but it does come naturally into the flow. So that's why, but I'm glad it's all right. Any other questions, everyone, by any chance? Are there general rules about auto-scaling in our case? So yes, that is also something, Jacek, we will dive into, whether we're reacting to scaling or whether we are scheduling it, and even then, how much, how little, based on what, and what do we consider? So absolutely yes, and that is something we will explore.
Yeah, especially I'm even interested in general rules like auto-scaling EC tools or means applications versus databases, or this kind of.
That is a very good question. This is EC2s specifically here. So auto-scaling comes in a few forms. Remember when we looked at DynamoDB, Jacek?
Yeah.
And we've seen the provisioned throughput, yes?
Yeah.
That is a form of auto-scaling, of horizontal auto-scaling. So this provisioned capacity mode is also a form of auto-scaling here. The one we're talking about is specifically EC2 auto-scaling indeed.
Okay, thank you.
No problem at all. And Andrew, absolutely right. We do scale from images. We use an AMI as a source for those EC2s, but in conjunction with other elements as well. That is also something we will dive into. All right, everyone. It appears most of the questions are coming relating to what we'll cover as well. So absolutely fine. That's what we will dive into those, absolutely. It's just that it's a pretty big topic and I don't want to rush this one. So let's have a coffee break here, as otherwise we'd have another hour to go through quite a while. So let's have a quick coffee break here and then we'll go until about 20 past or 4:30 British time before we go for a lab as well. Likewise, if you're looking at the slides and the content in terms of progress, if you will, we are leaving the two small modules of automation and containers for tomorrow. Like we said, day 3 tends to be the lightest material-wise. So we are addressing bigger topics today and yesterday, and we are leaving those smaller ones for tomorrow. They're more DevOps related, and they're more of a mention in architecting. Enjoy your break, everyone. I will see you all shortly. Welcome back, everyone. Hopefully, we are all back from a short but hopefully relaxing coffee break as well. So let's dive right in to actually look at some details here. But as we do, let's make it happen. So we have a nice and simple website here. Hi, this is Bertha. Hi, this is Mahala. Now, I am aware some of you have some elements of restriction corporate-wise, so possibly this might not work for everyone as it's not a completely secure website here. It doesn't have a certificate, but let's try. Is everybody able to access this? And the people that are able to, are you going through two different names as you are refreshing the page? There we are. Dave and Jacek is working for them and for other people as well, as I am seeing the thumbs ups. That is perfect. This, everyone, if you check the URL, is an actual load balancer, is an elastic load balancer. I have named it Application Load Balancer English. It will make sense why I've called it English shortly. But ultimately, it is a load balancer. So what I've done during break is I've actually configured one of these. So let's go to our EC2 portal here. Let's close some of these. There we go. Let's use this one. So from the EC2 dashboard, as the load balancer is technically an EC2 related resource, if I go to load balancers, I can go ahead and create one. Now I've already done so because it takes a few minutes to provision, but let's go through the steps. As we create a load balancer, we are faced with a choice: application, network, or gateway load balancer. And we will go through these in a second as well. But just to show you what's been implemented, we've placed an application load balancer. This is the cleverer one. It operates at layer 7 of the OSI model, therefore HTTP and HTTPS traffic. And if you create one, of course, you have to give it a name and then choose whether it's internet facing or internal. Ultimately, our architecture here is simple. But who's to say we couldn't have made it a bit more complex? Maybe we have something like this. There we go. Let's do this. And let's do this. There we are. And we have another layer of subnets here. And we have one load balancer here at the top and another load balancer here internal, because maybe in this particular case, we actually have a front-end, back-end, web tier, app tier, and database tier as well to process our front-end code, our application logic, and our database as well. This would therefore be an internet-facing load balancer. This would be an internal-facing one, basically requests going in these directions as such. And then, of course, to the database. Now, it is a VPC level resource. So we give it a name, demo, and we have to place it in a VPC. And notice, because it's internet facing, I can only place it in VPCs where it could actually reach the internet. So the console does help me figure out where I can put it. Then I choose the network, the subnet mappings here. Yes, it lives at a VPC level as a resource, but it does technically behind the scenes create endpoints within these subnets. So we don't technically see that, but what really happens here is it creates an endpoint through which the network, through which the traffic goes. Again, we don't technically see that as we set it up, but it's it becomes obvious through the selection of subnets. And technically, as you create the load balancer, you will lose private IP addresses as well by using the load balancer, because it will need to be reached privately through a network. Then you give it a security group. I have, of course, given it something to quite open so we can access it. And you point to a target group. The target group is the collection of resources that you direct the traffic to. In my case, I've selected TG1. But notice this. It could also send to Lambda or other elements as well. So if I go and create a target group, I could make more cleverer architectures where I could chain a couple of load balancers. For example, I could put a network load balancer in front and an application load balancer as a target later on. There are a few options there as well. I'm not going to create a target group here, nor the load balancer, because we already have one. But I could just go ahead and create once the configuration is done. And for those extra discussions that we had yesterday, just notice this. I could also add a global accelerator if I wanted to speed up requests from an edge optimized way to this load balancer. Just one element here, the target group is configured on a listener. In other words, that's how we define the network configuration of what traffic over what port and protocol we're sending the traffic to. And if I choose encrypted HTTP or HTTPS, I basically have to assign a certificate from Amazon Certificate Manager. Now, I should probably don't have one now. If I remember correctly, I did have one. I might have gotten rid of it, but we could do that as well to increase security here. It does take a few minutes to provision. And once it's done, it offers the application load balancer, gives you a DNS name. The others work a little bit differently. So let's now look at the differences. Application load balancer. As we mentioned, layer 7 of the OSI model. It's what we call the cleverer load balancer. Being at the layer 7 of the OSI model, it means when a packet of information comes through, it is able to check the entire payload. So the payload will contain IP, port, and protocol, source, and destination. It will also contain data such as Stefan, credit card, T-shirt, and why not, let's say, if the data is part of this. Naturally, this is an overly simplification in a more complex solution. Not all the data of a purchase would go in a single payload, but just to give an idea, let's say Nectar card, points, and what have you as well. But more importantly, the HTTP header, path as well, and verb. Exactly right, Arslan. It sees the traffic that comes from HTTP and HTTPS, and because of that, we can make more cleverer routing. So the listeners and the rules here, we can configure. I can manage rules, and I could, let's see on this one, add a rule, where I could say demo lambda, give it a name. As a listener, I could add a condition for this listener if the path is a certain path. So we're going to say test. If that is the path, forward to the Lambda target group. So let's do this over here. Let's give it a 1 priority. There we go. Now we have 2 logical choices here. One for the home page, or if no other rule applies, one for the path test. Let's create. Let's refresh. And load balancer. Let's copy the DNS name. If I go to the regular homepage, I'm routed to the same Bertha and was it Mahala? There we are. And now if I say test, there we are. I'm routed to a Lambda function. This is just a nice little Lambda function that says, instead of hello world, it just says that the application load balancer is routing traffic here. I've basically just changed the message, but it does go to show that a website, such as Amazon, for example, has a homepage. But if I go to today's deals, that will append a path to the domain name over there, and that is a path which ultimately takes you to what, in technical terms, is a different website. Overall, it's of course under the same application website, but as a functionality, this could be a different set of EC2s, maybe containers, maybe a static S3 website that we reroute requests to. It's a different set of resources showing a different set of code. And potentially, this is speculating on the architecture of Amazon, not confirming it, potentially it is rerouting it through an application load balancer based on a path. Highly likely it's more complex than that, but this is just to illustrate a purpose. Go ahead and test this if you want as well. Should work for you also. If you append /test after the DNS name of the load balancer, you should be able to access this Lambda function as well. Let's zoom out a bit here. And there we have it. I can see some thumbs ups, so it means it should be working. But nothing is happening here, no new EC2s. Well, that is because we really only just have those two EC2s. We haven't configured this or this. So we will do that shortly. Whilst we're on the topic of load balancers, let's address the others. Network load balancer is another type of load balancer, but it operates at layer 4 of the OSI model. Therefore, it really just sees this information. Because of that, it is not as feature-rich. But as a counterpoint, it is what we call the extreme performance one. When do you make a quicker decision based on an email? When the email is this long or when it's this long? Shorter or longer sets of instructions and details? Shorter one, absolutely. Less information to process, quicker response times, but not as many decision options, isn't it? Just to kind of illustrate that at a more human level, if you will. And there is also the gateway load balancer. The gateway load balancer operates at layer 3 of the OSI model, uses the Genevieve protocol, and it's meant for as little impacting performance as possible for the following purpose. I always like to check this diagram for it. Exactly right, Arslan. The idea is this. What we are looking at here is one VPC and another. Traffic is intended to come through here through this internet gateway and then get routed ultimately to this EC2 as its destination. But that doesn't quite happen. what happens is we get routed to a gateway load balancer endpoint. From there, we get rerouted outside of this VPC into this one, to the gateway load balancer, and from there on to one of these EC2s, let's say this one. Traffic response comes back to the gateway load balancer endpoint and ultimately to its intended destination. The reason for this is these EC2s here are designed to be firewalls or analytics solutions as well. They are trying to impact as low as possible on the latency of transmitting data through a longer flow by being at a low OSI layer, but it's basically a custom analytics and security solution that we can apply here. But that might raise the question, well, why don't we put this EC2 here? Why do we have to take the traffic out of the VPC altogether? Because what if that's not the only VPC? What if this is actually the case? And we have multiple VPCs that will basically require the same centrally managed firewall and analytics solution custom on those EC2s. Therefore, request comes here, endpoint, load balancer, EC2, and back here. Similar here, endpoint, EC2, load balancer, EC2, back here. And same here as well, of course, as well. It's going to be much easier to manage this solution centrally and scale it within that place over an entire organization, rather than doing it locally as well. So this is how we would use these load balancers, everyone. There are also different strategies of combining multiple load balancers together. Usually, or possibly, shall we say, we could have this as a network load balancer to quickly distribute requests based on port and protocol. Maybe we have different side ranges from different clients. And we actually route to application load balancers where we do more clever-based routing as well, once we get deeper into our application logic. So there can be various ways of utilizing these load balancers. There is technically another load balancer, but it's the one we don't really talk about, address, or really look into, because it's a legacy-based solution, and that is the classic load balancer. But if you're interested to learn a little bit more, I would say, do let me know. It's meant for the way we used to do things in the past with EC2 Classic, no longer as relevant. So we don't really address it here. Does that help, Arslan, paint a clearer picture on load balancers as
Yeah, it does. It does, but I'm slightly thinking elastic load balancer. I'm just trying to think, always in exam, also in use cases, like how can I differentiate between, I'm not sure, I know the difference between application load balancer and network and gateway, but the one you mentioned about elastic load balancer, I'm trying to think, how does it make differences, you know? That's what I'm slightly
elastic load balancer.
On that.
Sorry?
Okay, it's the features. Okay, that makes sense. What I know.
Elastic load balancer is just a generic term, is what they all are.
Oh. Yeah, fair enough. So I was thinking in my mind, I was thinking elastic bank is different, but it makes sense now. Okay.
No.
Yeah, that answered my
Sorry?
No, that answered my questions. I was thinking some different services, not possible.
No. My apologies. My apologies if I misspoke or if I didn't clarify that. It is the generic term, absolutely. It's like we say servers, and it could mean any cloud provider servers or physical servers. It's an overarching term. All right, everyone. Before we dive into the other facets of this, any other questions load balancer related?
Hi, Stefan. So for the application load balance, you gave an example of slash test. What would be the corresponding example for network and gateway load balancer? I mean, are we able to kind of filter it out on certain criteria? Any examples out there?
Not quite to that level of detail in that respect. So if I were to create a network load balancer, let's quickly make up one. It's not going to have the same filtering rules because quite simply, it doesn't really have that much to work with. Dual stack, that's fine. Let's go target group 2. Security groups, public as well. Load balancer. There we go. So if I go to the network load balancer here on listeners to look on that rule, not much I can do here. I can just listen on different ports and protocols. So I could add a listener and I could configure port 81, but that's about it. I can't really look at the packet of data and do too much clever routing there because it really just works on, right, this packet wants to go to that IP address. That's fine. That's where I'll send it to. Does that make sense?
Yeah. Yeah, cool. Thanks.
No problem at all. Let's get rid of this so we don't leave resources running. There we are. All right, everyone. In that case, let's explore auto-scaling and at the same time CloudWatch alarms, because they do go hand in hand for this solution here. Yes, please. Do we have another question?
Yeah. So just finally, the most clever stuff like filtering based on the header or body content of whatever we have inside the HTTP message, we can do with the first one, application based load balancer.
Yes. With the application load balancer, you'd be able to do that. So we only really configured a quick rule there, but if I went in and added other rules, sorry, not edit, we want to add rule. And based on a condition here, we could choose host header, source IP, request method, a query string. So we could.
Yeah, sure. And if we have, like, for example, we don't care about the stuff, but we care about the traffic. How to say, targeting traffic to different replications. We can use the other load balancers. For example, if there is traffic more than 1,000 per second, then we forward to the different replication. For example, we can do this with the other load balancers.
So for more volumetric requests, we would use network load balancer, but we couldn't configure as much as where it goes. So we can say if more traffic comes in, shift load balancers per se, because that is an endpoint that we're sending the traffic to.
Yeah.
That might be a solution where we should look at perhaps putting API gateway in front and checking various other aspects in that respect. We could have an architecture where, let's go to API gateway. We will explore this briefly tomorrow.
Okay. So yeah.
There are options, Jacek, absolutely. I don't believe a load balancer could check based on the volume of traffic to shift, though. So.
Okay, there are better solutions for that. Okay. Yeah, thank you.
No problem at all. All right, everyone. So since our next activity will actually be lab number 4 in about 20 minutes time, half an hour, please go ahead and launch lab number 4 so it's ready for us once we get to it. And of course, In the meantime, we will go through our remaining discussion there. So this is the link, lab number 4, everyone. Just so it's ready for us. Here we are. Let's sign in here. And lab number 4. This way we'll have a chance to provision as we are finishing the module. There we are. So let's have a look at auto-scaling now, because auto-scaling is the ability to respond, as we've seen in theory, to changes in a metric or changes in a state, to some changes essentially. Now, essentially, we have to choose how we respond. And then, based on the auto-scaling group, which is defined with a minimum and a maximum, we add or remove instances. Normally, there is a predicted demand, but as we know, realistically, that's not going to happen. And in traditional cases, we would have prepared for that estimated demand by buying more servers or abruptly increasing capacity. Whereas actual demand fluctuates, and we might have over-provisioned resources or under-provisioned resources at different times. The ideal way is to have this kind of solution, which is what elastic cloud resources can achieve, so our EC2s, for example. But how does an auto-scaling group know what EC2s to give you? How does it know to give you Windows or Linux or Ubuntu or Red Hat or those kind of software configurations? We save it in a launch template. You've actually seen me do this on day 1. Because what I've done on day 1, I launched an EC2 really, really quickly without actually configuring it. Because instead of going launch instance and going step, I have a launch template, which is really just a series of those steps saved as one of these documents. If you see here, it's basically the same configuration, AMI, instance type, keeper logging, network, storage, and more. But instead of launching the instance, you just say create launch template. It is versionable, and you can see here I have different versions as well. You define all of those aspects, and that's where auto-scaling knows what to give you when you reference it in the auto-scaling group. And then it shifts the desired capacity based on scaling policies to give you more or fewer instances. So let's actually configure that and actually make it happen. Because again, during break, I actually did provision an auto-scaling group, but I did not provision a scaling policy. It's created. We will go through the steps as well ourselves. And I will go to automatic scaling where I have nothing at the moment. But I will create a dynamic scaling policy. I will call it target tracking. There are a few other ways to react dynamically, and I'm not going to do it by CPU, but rather per refreshes to the load balancer, but more technically request count per target. I'm going to give it a value of 10. So at 10 requests and as an average over, I believe, 5 minutes, we should scale. I'm not going to hit create quite yet. This is an auto-scaling policy. However, normally you would create a CloudWatch alarm first, those kind of elements, and then configure an auto-scaling policy. This is just the console's way to help us out. So there we are. I went to auto-scaling, to CloudWatch alarms, and you can see I have a few already. Let me actually get rid of some here. I know why I have so many. So we can see things a bit more clearly. It's because of this reason here. Good. We've gotten rid of most of them. So there's 6 current alarms configured. You can already see all the 3 possible states on these alarms. They're based on different solutions here. That's perfectly okay. Once I hit create in this dynamic scaling policy in auto scaling, a new one, a new alarm will appear here. Target tracking for the auto scaling group. If we check its configuration, there we are. It says 10 data points, sorry, the value of 10 for 3 data points within 3 minutes. So that is essentially saying in 9 minutes of consistent 10 request usage, we will scale. So if anybody wishes to give me a hand and refresh that load balancer a few times, consistently throughout the next 10 minutes, that will be highly beneficial, but I will do it as well. This is a very new alarm, so it's gathering data as we speak. The metric is there. The alarm just has to graph it out. There we go. You can already see in the past, it would have breached the threshold. But since then, we've gone ahead with other explanations as well. So we'll continue using our load balancer, and this graph should go above the threshold shortly. We can, of course, create other alarms based on other metrics, including billing. So I could select metric for different alarms. There we go, even for custom metrics. So this is the one I was looking for earlier. And you can see it here. Stefan Demo Service is really just a metric that I've pushed programmatically. And it's just to say, maybe you monitor a particular metric on your website as a clickstream solution or page views, different options. But we will go with something else here. We will go with billing. For example, by account, by service, total estimated charge, and more. There we go. You can see the graph or total actual cost. Let's say by linked account. There we go, 3 possible accounts here. Let's go with the most used. This should be a steadily growing one. There we go, you can see how it grows. Once you pay the bill, changes again, and more. And once you have a metric, then you define those elements. What are you looking for? The maximum, the average as well. Different options. For billing ones, it's quite clever in the console to also let us know. Periods as well, we can make this more customized also. Greater, lower than a threshold. And then you choose what happens. Some built-in actions here, such as a notification, auto-scaling action, systems manager action, or we could just not do it from here. And in EventBridge, I can basically make it as custom as possible. Remember EventBridge, everyone? We did mention this before. In the very simplest of ways, EventBridge is a solution where if something happens, something else happens. I know it's a vague technical explanation, but it's just meant to illustrate the flexibility. If I create a rule here, demo rule 2, I can choose AWS events as source event for my event bus, other events, all events, and I can custom enter my event as well. Now I'm going to go for an AWS event because I want to show you that we can also use CloudWatch alarm state change. In other words, we can say, right, our CloudWatch alarm went from OK to in alarm. So it triggered. What would we like to happen then? Well, maybe I don't want my my auto-scaling group to react, systems manager or notification. Maybe I want a custom API destination, create on a new API endpoint. We could say post something to an API destination endpoint. This could be, let's say, I would have to dive deeper into the architecture, but purely at a high level, imagine you configure an alarm based on the so you configure a custom metric as, let's see, as nectar points. And am I assuming wrongly here that we are utilizing nectar points as part of our solutions, or would you like to give me a different metric? I'm thinking more along the lines of customer loyalty programs. If you are happy to give me one of those metrics more tailored to you. Any thoughts by any chance? Or yeah, nectar is a big thing. Nectar is good. Okay, let's go with that. So imagine you have customers spending nectar points and they're spending a lot. Maybe you allocate another reward or a voucher or anything. They spent 1,000 nectar points, for example, and you get an alarm which triggers an event to post to a custom endpoint, demo rule 2, as well. So let's choose the CloudWatch alarm, state change, and we choose a custom endpoint that you have. Let's see, https developer.sainsbury / API path 1 nectar rewards, for example, which calls an API on the post verb to maybe send an email with, hey, thank you for spending that much with us, here's £5, or thank you for being a loyal customer, any sort of reaction really. Or reverse, they spent the points and you can say, you're running low on nectar points, we welcome you into the store next time, or different possibilities. The idea is it's highly customizable. It can do more than that. EventBridge doesn't just trigger based on invocations. You could also perform a scheduler. So you could do it on a rate-based or cron-based solution here, where we could configure at a recurring interval, maybe every 5 minutes or 12 hours or 5 days, we remind about promotions and the like, because it's ultimately just an event that's being sent. So let's give this time zone. You decide when to start, when to end the promotion as well. It does have to be in the future though. Flexible time window as well, absolutely. And then you choose what API you would like to call on that schedule. Lambda function, and again, your Lambda code will be flexible to do whatever you tell it to do, or other solutions, even custom endpoints we should be able to configure here. So we have templated targets. Let's see, do we have a custom endpoint integration here? Doesn't look like it, but if not, we could route it through an API gateway as well. So it is ultimately possible as well. So quite a few different clever ways that we can respond to alarms, everyone. And if we checked our website now, after we've spent some time talking, for EC2s, autoscaling took action whilst we were looking through different services. Our autoscaling group, we can see in activity, is launching 2 more instances, which happened just a few minutes ago, which, if we check our metric here, it's already an alarm. And there's a huge spike here. No wonder we've gotten a little bit more capacity there. It will dial down, and I can foresee the question: will those EC2s go back now? No. because I've only created it as a scale out policy. I can choose to make a scale in policy as well. That is also perfectly possible. But I'm usually leaving this one as a pure scale out because otherwise maybe we carry on talking and by the time we come back to it, we've already also scaled in. So it's a bit of a wasted opportunity there in terms of a demo, if you will. So everyone, just to reiterate how auto-scaling works here, again, we create the group, we give it a name, demo ASG, we choose the template here. Notice how it tells us the AMI, keeper, security group, instance type. We go next. We put in a VPC, of course, just like we've also drawn. I have to put in the same VPC as the load balancer, or as best practice at least. Public 2, there we go. Attached to a load balancer, because we want to make sure the new EC2s will be registered with the load balancer. So as we spin up new EC2s by scaling, you've seen we directly got routed by the load balancer. I didn't have to configure anything because the target group and the auto-scaling group overlap here. They are connected to each other. There we are. I'm choosing the type of target group that I want. I can configure additional health checks if I want to. Elastic load balancers actually perform health checks on the endpoints. More detailed metrics if I want to. Choose the capacity and lightheartedly the scaling policy here, because normally we can make more configurable choices post creation. Let's cancel out of this one. And once you create the auto scaling group, there we are. In automatic scaling, you can choose the dynamic, the reactive, the ones that trigger based on a metric, or the ones that trigger when you tell them to trigger. Maybe I don't want to scale out the metric because I know for a fact on the 19th of October at 8 o'clock in the evening, I will run a sale. So that is expected to generate traffic. So I want 10 EC2s, minimum of 10, maximum of 20. Why? Or let's say minimum 5. There we are. It's more than I have now. I have 4 now. Why am I not scaling to 20 or to 5 in this scheduled one? Why am I still giving 2 values when I know I'm going to have traffic? Well, cost in a way, Nikos. What if I'm wrong? What if I guesstimate wrong how much traffic I will have? What if people just simply don't visit the website? That's fine. We can mix and match. We can schedule 10 EC2s for 19th of October, but then if traffic is much more than I anticipated, I'm also going to dynamically scale more. And then there's predictive scaling, which essentially looks at previous usage, leverages machine learning analysis of your previous solution to look and estimate how you will need to scale. It does a best effort analysis on previous usage patterns of your workflow to give you the best possible, in light of recent data, type of capacity. So you don't need to manually adjust the rules. But the idea is you can still mix and match. Perfectly possible. almost to the end here. I have EC2s from an auto-scaling group where I have minimum of 4, maximum of 20, and I have running, so desired 10. How am I paying for them? What do we think? So being EC2s, we are paying as they are running. So if they are on, we are paying as they are running. So Andrew suggests on demand. Any other suggestions? Would anybody use spot?
Sounds like a good option, but what if they weren't available?
That is a very good question, Andrew. Absolutely. For the person that's messaged me privately, I will do my best to make it happen that way. It would be unreliable, potentially. Notice what we can do here. As I configure the auto-scaling group, let's edit the pattern of this, actually, automatic scaling. Let's see here. Launch template, there we are. I can override the launch template, and this is something we very briefly looked at earlier. I can change, I can say 50% on demand, 50% spot, and I could say how much I want as base on demand capacity, so as a minimum, if you will. Also, I can adjust this. Maybe I want capacity or price optimized, and I can rebalance capacity as well, because ultimately, if there's no spot, I might want to go back to on demand. So I want to take advantage of cost savings if there are any, but I also don't want my solution interrupted. And that's the one, Arslan. Should we use savings plans here? Yes or no? Because technologically, it is possible.
So don't savings plans just auto adjust? So if you're basically buying a hunk of compute, and if you use it, you get the savings, but if you don't, you lose it, sort of thing.
Absolutely. So let's assume this is a test website to run only for 2 weeks. I wouldn't purchase savings plans for that. 2 weeks is nowhere near the 1 year. What if this is the Sainsbury's website that does run continuously? Therefore, maybe we can get the savings plans for the minimum capacity that we have in auto-scaling, because that is meant to run continuously. You're absolutely right, Andrew. It will be, they will run on demand, but if it matches the savings plan contract, they will also be discounted by being as per the savings plan. And since we're running them at a minimum, we will always have at least that many EC2s. Does that make sense?
Yes.
That is perfect. So everyone, ultimately, there is quite a bit of flexibility here. Mix and match scaling policies, mix and match cost abilities as well with auto scaling. It offers quite a bit of granularity and detail into how you scale, and you can choose different instance types as well. You don't have to just choose one. One thing we didn't have a look at in detail here, because it was kind of tangent to our high availability concept, is logging as part of monitoring. Really just an add-on to the high availability aspect, but it is important for observability. So we have had a look at logs throughout the course. It's not a new topic now. We've had a look at CloudWatch logs. We've seen as part of our extra learning discussions that in CloudWatch, we can send data in form of logs from many different places. So CloudWatch creates log groups for services that send log data. And logs are really just records of events. A Lambda function was invoked. An EC2 was terminated. A user logged in. These are all events, and they get logged. Now, not all of them get logged in CloudWatch logs. Not directly, at least. API calls, such as logging in, launching an EC2. Those are API calls. They get logged in CloudTrail. VPC flow logs look at network traffic information, such as this. A flow log checks the VPC, the subnet, or the Elastic Network Interface for this type of information, layer 4 information of the OSI model, source and destination port, source and destination address, and protocol bytes and packet size as well. There are many other services that create logs and different logging formats and data as well, but the point is all of it can be sent to CloudWatch logs, even custom logs, much like custom metrics. And we've seen how this would look. Let's say we go to this Lambda function here, and we can see different invocations, and we can have a look at the different data about this log. We can see timestamp, details here, signature version, and initialization duration, so cold start, memory used, build, and so on. And CloudTrail more specifically is logging API calls, answering some important questions about those API calls. Who has done what, when, where, how, and there is one more question, arguably the most important. Can anybody guess which one that is? So we have when on the board. Let's see. If we're not sure, please give me a question mark in chat. I always get the suggestion of why. I'm afraid that's not something we can actually answer that easily. It's more of a human aspect, isn't it? Let me ask you this. What will happen if I run this API call on this instance? There are two possible outcomes here. Nothing, or EC2 terminates. So it answers the question, everyone. Did it work? Success, failure. The logs look at the user identity or principal identity, such as Alice, this IAM user. What was the request? What was the focus of the request? So the target of the request, which was a particular instance, and the event was to stop it. That was the request, but did it actually work? Well, we have a previous state of running and now of stopping. So yes, it did work. Success may be considered differently depending on the actual API call and event, but ultimately, if it fails, you would have an error code. So that would be the telling aspect of whether or not it went through. Any second now. There we are. Cloud trail. And if I check an event, this one actually, interestingly enough, client dry run. So this one actually failed here. Interestingly enough, minimum max count. Interesting. It might have been through me configuring that auto-scaling group, but not actually running it. That is interesting there. But we can check others as well, put evaluations and more. So there we go. You can even see auto-scaling registering targets and auto-scaling performing API calls. This is not me. The principal is auto-scaling. It's the role for auto-scaling, actually. And if there is no error, it just means it was a success response, ultimately. So everyone, in conclusion, to implement high availability, take advantage of observability options with CloudWatch, CloudTrail, and more. Not just these services, there's X-Ray, there's VPC flow logs, there are S3 server access logs, and more. Implement load balancers as a way to distribute and channel multiple of your requests in an organized way. It doesn't have to be evenly balanced. You can configure the rules. And take advantage of auto-scaling group with varied scaling policies to scale based on different requests or events. Before we go for lab, everyone, do we have any questions on any of these technologies that we looked at here? Or are we okay? +1 or thumbs up in WebEx. That is fantastic. I can see the thumbs ups all around. That is perfect. Like yesterday, if there's anything you'd like to adjust, please let me know. But I'm hoping the format, the depth, the pace are still working okay. But as always, if there's anything I can do to improve your experience, do let me know, please. And I will do my best to implement it. Tomorrow is going to be a shorter modules day. So we have a few modules, but they're all more shorter mentions. And I hope you agree with the decision. We haven't really done the knowledge checks so far because we really are addressing a lot of questions as we go along. So it's kind of like a reverse knowledge check, if you will. But I will compile multiple knowledge checks into a whole quiz so we can do tomorrow morning to simulate that exam scenario. So we'll have about 20 or so questions quiz. It's going to take us about 20 minutes or so to go through those questions. Absolutely, Arslan. So we will do that as well. But instead of kind of interrupting it here and there with the various ones through the course, we'll do it as a more dedicated section also. Exactly right, Arslan. To have a good view of the exam, they're going to simulate the style, but not quite the depth. They're easier than the exam questions, I would say. The exam questions are slightly harder, but at the end of tomorrow, I do go through what you can expect from the exam, and you can, of course, let me know if I can provide more details. So everyone, lab number 4 until finish, or later if you want to as well. If you decide to leave, let me just say thank you very much for joining me today on architecting on AWS. Hope you've enjoyed. Hope you've learned something new as well. And I will see you all tomorrow morning if you decide to leave as well. Otherwise, I will be here, of course, for everyone until every last one of us finishes. Thank you very much, everyone. Have a great afternoon and enjoy the lab if you decide to do it now as well. Thank you, everyone.
Thank you.
So for the private question of whether we get the whiteboards, yes. Recordings, I'm afraid we are not recording the sessions, and if some are recorded, it's more for internal purposes, but we don't share recordings of sessions, I'm afraid. Whiteboards, absolutely. Recordings, I'm afraid it's a no on that answer. No problem at all. Thank you as well.